next week, we'll be here. That's why I like to say, like, I'm not going anywhere. All right, let's make sure I get my chat running also on these platforms. This will eventually load, I'm sure. Cool. All right, we're live on TikTok. Let me get a connection. Let me get a connection on YouTube. Come on, YouTube. I know you can work today. You can do it, YouTube. Really? Ethan, what's up, dude? I haven't heard from you in forever, dude. What's going on, Ethan? Ethan.
Hello.
How's it going, dude?
Well, it's not really the best right now.
Oh no, what's happening, dude? Let us know. What's going on?
Well, first of all, I need to talk about what's happening. It's not like as if I'm going away and it's like a fluctuating process. It's just I'm busy with other stuff, so like,
that's okay. Life gets busy sometimes, dude. Yeah, I get busy with shit all the time.
Okay, but yeah. So I haven't even told you about the Nintendo Switch ever since I got it, right?
Yes, you did. You won the Nintendo Switch for our summer camp, which was great. Is the Nintendo Switch? Is it still good? Is it great?
Yeah, I've had it for a good month now, and to be honest, I like it. I love it, actually. I love it.
Good. You came with some games too, right? You came with like Mario Kart or something at least.
Yep, I did. It did.
Sweet.
But yeah, so I'm enjoying it. I'm actually enjoying the games, and I'm installing some of my own.
Good.
But it's like I'm also focusing on school right now, and it's not treating me the best at all.
I know. Yeah, because you graduated high school last year, right? So now you're going into like harder stuff, yeah?
This year. I graduated high school this year.
This year, sorry, you graduated. But now you're doing harder, like math, right? And harder computer science stuff, right? Harder courses.
Yeah, it's like, I just had this project to do with like, you know what a finance tracker is?
A finite structure?
No, finance trackers.
Oh, a finance tracker. Yeah, I mean, yeah, finance stuff is all the rage. It's pretty cool stuff, yeah. I know about finance.
It's like ever since the beginning, this professor has been giving me only questions about finance stuff, and I know nothing about it. Like, literally nothing. Talking about something like
I honestly don't know much about finance either. No. But it's a great way to make money if you know about finance. Finance, especially like fintech, finance tech, is like a huge field.
Like, I think I know a little bit of finance, but I don't know the big stuff like such as personal reliefs or adding a record and sorts.
Sure, there's a lot of jargon, right?
Yeah. I have a project on that. I'm trying to ask ChatGPT to like help me break it down this process.
Good. No, ChatGPT can definitely help. Yeah, especially with like jargon stuff. Yeah, ChatGPT is great for that.
Yeah, so
everything.
Like I was asking like ChatGPT to help me, but instead it had to write down the whole thing for me.
Yeah, so I mean the thing with chat is you don't want to be like copy pasting information that it spits out. You want to kind of read it, internalize it for yourself, and then come up with an idea of it, right?
Yeah, I want to use it for ideas.
Yes, yeah, it's great for ideas. I use it all the time for ideas.
It's like the worst thing about it is that it's like it basically just did the whole thing, and I'm trying to understand it. And I mean, while I do get it, I can't find a way to really put it into my own words. Like,
okay,
like if you know programming and variables, I'm trying to make different variables so that at least the teacher doesn't see it was AI generated. But
I see. Okay, you're having a hard time coming up with something unique because you're kind of like, your brain is getting lazy. Your brain is saying, and this is a common thing with AI. No, it's not that it's lazy, but it already sees the answer, so it's hard to come up with something different, right?
Like, if I come up with something different right now, I will lose track of everything that has just happened.
Yeah.
One small change can alternate the whole program in and of itself. It's like, now
you're having it write the code? Is that what you're doing it? You're having it write the code?
Like I'm saying, like the code is already written, but if I go ahead and try to change it into my own words, it's not going. I might just get lost in the process.
Okay. Well, this is also where like you can ask AI like along the way, like to explain different steps and parts and stuff. and it can do it. Yeah.
Yeah, it's speaking of explaining, I have the right comments. So, I mean,
Mm-hmm.
I have no problems with that. I literally have no problems with that. Comments are like one of the best things for me. So, I'm not having an issue with that.
Okay.
But you know what's worse? You know what's worse?
What's up?
Having a test you were that you were preparing for, but you still didn't do well in.
Yeah, no, I know that happens a lot, man.
Like literally just today, I
Uh-huh.
took a test and like I struggled on the programming thing. Like I don't even think I'll pass that thing. So I like with a maybe with a 70 or even an 80,
But
but definitely
the
not
other thing to remember, Ethan, it's just one test, right? So even if like you
just
don't
one
feel
test.
like you did the best on that one test, right? You still have more opportunities to do more tests. And
Like that was the last test.
okay, but did you do well on all the other tests?
I
I
got
think you probably
80s on
did.
both tests. I
Okay.
got 80s on the other.
That's decent.
And guess what? The final examination's coming up soon. I
Yeah.
am not sure how I'll do in that.
So, okay, when you get your exam back, look at what happened and try to assess anything that you didn't understand, and then those are topics for you to reinforce, right? So you probably did better than you actually think you did. It's very common for students to take a test and be like, "Oh man, I just bombed that." Like I'm gonna fail life. Like nothing else will come of this. I'm gonna be working as a garbage collector for the rest of my life. But once you get your test back, you're gonna see you actually knew a lot more than you thought you did. Your brain just hyper fixates on the negative things sometimes, versus appreciating the things that you did well and the things that you do know. So I think you'll feel better once you get your test back. And even then, even if you don't do as well as you wanted to, it's a learning experience to be able to see where you weren't as strong and then refocus your efforts into be getting strong at those parts. What's up, Kubi? Favorite millionaire professor? Not yet.
No.
Well, I mean, to be honest, now I'm just questioning like how will my life go in the future? Because I signed up for programming as my major,
Yes.
and this is just the basics, you know. This is just the basics of programming. I don't even know what it is for me to for the rest. Like,
oh, and it's difficult, and so you're starting to like question your career choice. Is that what you're saying?
I'm rethinking about life in and of itself right now.
Yeah, well, that's okay, dude. I have a really great metaphor for this. So, well, not great. I have a great like story. So my roommate in college, his name was Matt Ridge. He failed calculus 3 times. Like, he had to retake calculus 3 different times before he finally passed it. And calculus was like a requirement for him to get into doing chemical engineering, like biochem type stuff. But he never quit. He eventually passed it on like, I think his 4th try. And now he makes like 4 times the amount of money I do. Like, because he works for a plastics chemical company, I think up in Boston, and he's like developing like the latest petroleum products and stuff. But the important thing here is that he didn't let failing a class deter him from like pursuing his dream of like working in biochem stuff. So if you really want to do something, don't worry about like the setback of, you know, doing poorly on a test or maybe even failing and having to retake a class. That doesn't define you.
I guess you're right.
Yeah,
But
I'm
like,
sometimes right. Sometimes I'm wrong. I might be wrong with this question, honestly. I've been doing this one.
But like, you really believe that I could achieve something in life?
Yes, you can definitely achieve, dude. You've achieved so much in life already. I think that's other very important thing to like notice.
I would want to know.
You want to know what you've achieved? I mean, you've been like one of the most successful people in my Discord, dude. What? That's pretty successful. I mean, I hope that is like a badge of honor. Like, you've been one of the most active. You've had some of the greatest growth. You know, you've been over the years have asked tons of really great questions, and you're very driven at like improving your own knowledge, which is a very rare thing. Most people don't give a shit about getting smarter. So I think you should take that as a huge, you've already accomplished something.
Well, I guess I've heard that from other people, like saying that how I'm ambitious and like I want to achieve high and like I want to pass with that
Yes.
4.0 GPA.
Yes.
Those are things I'm getting from a lot of people.
Good.
Even my teachers are saying that.
Good.
Even they
Yeah.
are.
Well, I'm glad you're hearing it more and
But,
more. Yeah. No, it's true.
but yeah, before you get really quick before you get into your question, it's like I just have the program. I have my program ready. And I'm not
Okay.
asking for you to look at it, but it's like I'm just questioning. I'm just. It's like I wonder if I'll ever do well because that final examination is coming up, and you know I'm just worried for that. If I
Yeah.
did well, if I haven't even gotten a 90 on this, what makes you think I'll get a 90 on this examination?
Things can change, man. You know, by the same token, I've had people who are like doing excellent in classes, and then they take their foot off the brake, and then so they stop trying as hard, and then they end up like failing the class on the final. So I think the fact that like you're putting efforts to getting better and you want to do better after this exam, I think you can totally turn it around and do well in the final.
Well, there is one other thing. So I think most people also like didn't do that programming question correct. Here's one
Sure.
thing. This professor is using this book where literally she got the question from the book and I never even looked at it. Like,
Yeah, I
until
know.
now.
Yeah, I know.
Like
Teachers are lazy, dude.
This like I'm not kidding here, but this makes me just feel bad. I want to cry for myself because like how did I not look at this until now?
It's okay, dude. I overlook things all the time. You can't be looking at everything. You're gonna miss shit. Like that's called like situational awareness, or what is it called? Like being oblivious. Like I've definitely been called by like ex-girlfriends as oblivious. Because I don't know, like I sometimes hyperfixate on certain things, and that causes me to miss like the obvious solutions in other areas. But it's okay. People miss stuff all the time.
But yeah, I mean, now that this is here, and I feel like most people will not do well. I'm thinking.
Then you should do well.
I asked, yeah, but I asked my mother, like, wait, sorry, not my mother. I asked my professor if like she would actually give extra credit, and she said she
Yeah.
would think about it. But as I'm
Nice.
looking over this book, I'm thinking to myself, should I start off early and trying to like not programming itself because that would be way too much. But they have like short answers, and I'm thinking to myself, should I write this on folder sheet and just give it to her because I feel like I could do something.
Yeah. No, I think if you showed teachers an initiative, that you want to get better, you want to do extra work for extra credit, the worst they can say is no. They're never going to punish you for that. So, if anything, it'll at least like put a good image of yourself in your teacher's mind. And believe me, trust me, like when I was at UCLA giving out final grades, I 100% considered whether a student was active, whether they participated, whether they showed up to office hours, whether they like, send me emails, wanted help when determining what their final grade was. If they were like on the border and like I could bump them, or I could be a little bit more forgiving on the final exam, like on giving out partial credit, I 100% considered who that student was as a person. And so if you're showing to your teacher that you give a shit about your education and you want to do better, even if it's not like documented, I guarantee you that sways how she grades your exam later.
Well, I mean, she did say, like, you know how in like situations where if you have like since for me in my school, the highest you can get is an A, which is just a 90. The thing is that there are some situations where students end up with either 88 or 89, depending on how they did on the course. The professor might just bump them up to a 90.
Exactly. Yeah, the bumping happens all the time.
I questioned this to my professor, and she just said maybe she'll do it.
So yeah, no, because she doesn't want to. She doesn't want to. You can't like bind your hands and tell them that you as a teacher or professor or whatever. You can't explicitly say you're going to do this because then everybody starts to bug you for it. But yeah, I know what she's doing. She's saying that she will, but she can't explicitly tell you that she's going to, because then it becomes one of these, I'm going to hold you to it type things.
Yeah, I mean, since she's getting some of the questions from the book, I'm thinking to myself, all right, maybe she will not check these, but like, I feel like it's a good idea for me to write them down.
Yes.
And by the time examination comes, I can use these as reference, so that by the time examination comes in, I know most of the things if they come back up.
I think that's a great study strategy. Yeah, 100%.
because I've heard that writing helps you process information. To be
Yes.
honest, these fill in the blanks and short answers kind of
It's the difference
kind of
between
go.
passive learning and active learning. So if you're just like sitting there like watching videos and just listening to lecture slides or reading notes, you will learn a little bit, but you're not going to learn as much as you would as if you were to actually do something. So like doing homework questions, like committing like pen to paper, for whatever reason, it helps you learn more. And I know this because I even have like some really high up neuroscience PhD friends, and when they go to meetings and stuff, they bring a pen and paper. And you got to think to yourself, well, if these like PhD neuroscientists are using a pen and paper to, you know, write down their ideas and like learn things during meetings, they must be onto something. So I think it's 100% a good idea to just like do things by hand.
Well, I mean, I plan to initiate this by tonight. To be honest, I have a take-home test right now, so I think I
Cool.
should do that first.
Yes.
Yeah, I think I'll do the take-home test first, although I'll have to go quick because the notes are there and I only have limited time. And then I feel like starting to do the questions on photo sheet and
Yeah.
then like show it to her tomorrow if I could.
I think that's a great
Thinking,
idea.
I'm thinking if I should initiate that plan. So
Yes.
well,
Initiate
I
the plan.
might like the one thing I'm telling myself right now, I might not earn extra credit from this, but at least I'll learn knowledge so that I do not
Yes.
flunk that
And that's the goal.
test, that examination.
Grades are nice, but knowledge is the true reward.
That's what I'm
Right.
thinking. So like,
Good.
should I stick to it? Because
Yes.
I have my mindset where once I have a goal, I am not letting that go until it's all over. Like
That's great.
that's what I'm thinking.
I think you should do that. Yeah. Let me work on this question, Ethan. I gotta do some stuff on the stream here, but yeah, I agree,
So much
Ethan.
of your time, but
you're welcome. You're more than welcome.
I might ask a question. To
Yes. Yeah. Put
Just let me-
something in the queue. I'll do it. Cool.
Hello.
Okay. Awesome.
Hi.
What's up, Ramton? How's it
How
going, bro?
We're good. How are you?
Good, man.
Yeah, I've lost the privileges of being able to join the chat by myself.
Really? No, you're an
Yeah.
admin, dude. What? You're an associate professor. You should be able to do it. Really?
So, yeah, for some reason it doesn't let me. I had to like ask for like permission.
Oh, all right, whatever. I'll fix that. I don't know.
Yeah, of course.
You're good. I mean, Ethan can get up here, and he doesn't have some of the perms you do.
Yeah, I don't know. Maybe some Discord maybe it might be.
I think Discourse is fucked up. Yeah.
Did you do the 10-hour stream?
I did. We did the 10-hour stream on Thursday. Yeah. I saw
okay.
your Discord message. I was gonna answer to it. Yeah, no, it was great. Yeah, we had I need to tally up how many questions we did, but the queue was getting like over 20, like a lot. Like I had to like midstream, I had to go into my code and change the variable so that it would accept more than 20 things in the queue. Because I was like, oh, we're hitting.
Oh damn.
Yeah.
Okay.
So yeah, it was great. There were a lot of people. It went well.
Yeah, I wanted to join, but I had to teach you like.
Yeah, you had to do Muay Thai.
later.
It's all good. It's all good.
And then
It's all
after
good.
that, it goes very late. But yeah, I also took a look at some stuff like that. But maybe I'll chat with you later offline.
Yeah, about
like,
setting up. Yeah,
couple.
let's get you on, dude. Let's get you on. It's starting to get more and more busy, especially as we get towards the end of the school year. Is this
right,
linear
right.
algebra? It is. Do you know how to do this, Ramton? Maybe do you want to you want to hop in and do this one for me? Because I don't really know how to do this type of stuff.
Okay. I have to. The proofs, the answer to both of them. The first one is
Yeah.
a lot easier. I feel like I'm trying to think of the rigorous way of doing it, but I'm trying to see how that would work. But essentially, the first one is the columns of the vector A. So, like, if you have
You had A,
some
which is like
matrix A.
right. A, which is like a matrix, which looks like this, right? Well, there's a bunch of
Yeah.
these, right?
Yeah, so exactly. Yeah, so you can say like it spans by a bunch of like different vectors.
Okay.
So
But
you
if
can say like
if all the
E1
columns
would be
if all the columns span it, then doesn't that mean that, well, first of all, the rank is then not 0, right?
N.
The rank in this case would be n. Yeah, right. If it's n by n.
Yeah, because you can say it's because there is the rank nullity theorem as well, which says that the total rank plus the the dimensions of the rank plus the dimensions of the nullity has to equal to the dimensions of the space.
Right. Rank plus nullity has to equal n. I remember this.
And yeah.
Good.
And then for this one, because all vector all of the columns of A span the space Rn. What you can say is like it's spanned by a bunch of vectors like v1, v2, all the way till vn.
Yes.
And then the dimensions of A is the same thing as the dimensions of the row reduced version of
A, right? Which means the rank is 0, or no, sorry, the rank is n. The rank is n. Sorry.
Yeah, rank is n. So essentially, you just have to show that if you were to to find the dimensions of A, because it's equals to the dimensions of the row reduced version of A, and considering that the columns of A span the space Rn, the row reduction of it would have a leading 1 in every row.
They call these the pivot points, right? Are these called the pivot points?
Like what is it? Which one?
Pivot points? I think they're called pivot points in matrices, right? Pivot points in matrices.
I don't know that term, to be honest.
Is this I don't know what FM is. You tell me. This.
Pivot point.
They're called pivot points, I'm pretty sure.
Oh, okay. I think I read them as like the rank, the leading 1.
Like this. So, for instance, this would have rank 2, right?
Yeah.
This, is this technically rank 3?
Rank
because
3.
Because I could use this last, row, right, to kill out the 2 on the second one, right?
Technically the other way. You can use the third row to kill the second row's 1, and then actually you're right. Yeah, the last row also kills the second row's last 2. Yeah. So your leading digits are 1, the third row 1, and then the fourth row 2, which technically you can just reduce it.
Oh, I see. Well, because this second row is a linear combination of the third and fourth.
Yeah, exactly.
It's literally row 3 plus row 4.
Yeah.
Oh, okay.
Yeah. And then that only happens if you take the reduced row echelon form.
Yes.
So I guess the row echelon form is when everything starts with a leading digit. Reduced the row echelon form
is where everything starts with a 1.
With a 1, yeah.
Got you. Okay.
The RREF of A would have a leading 1 in every row, which would have dimensions n. For that last problem, and then if it has dimensions n, then the rank. Darth
Gonk is asking, I don't get linear algebra. I'm not taking it, but why is it a thing? Why is linear algebra a thing? That's what someone in my chat's asking.
In so much different stuff. Like you can use it in quantum mechanics.
Yeah.
You can use it in finance. You can use it in statistics. Like pretty much any area of math, you would use linear algebra.
It's used for, so this is the example for like quantum mechanics. It's used for like creating like bases for like quantum states and all sorts of like energy stuff, and I don't know. But yeah, and then you're also right with anything that involves large amounts of data, which is usually stored in what are called arrays. Arrays are matrices. And so being able to do like cool math operations on big sets of data, that's linear algebra. Except aerospace. Aerospace 100% uses linear algebra, dude. What? Bro.
Yeah, aerospace would use 6x6 linear
6x6. Yeah.
Yeah. Because they have the X, Y, and Z, and then they have the 3 rotation directions.
Exactly.
So,
yeah.
I guess the first one is wrong because the dimensions
this one's
are
false.
0,
right? Yeah. So the dimension of the nullity should be equal to 0, right?
Yeah.
Okay. And so let me, just for my own sake here, sorry. When we say the columns, which in this case are that's the basis, right? Those are the basis vectors. Span Rn.
Each column is a vector.
Each column is a vector. Those are what are required to describe the space Rn, right? So I think in like a simple case, if I wanted to describe like R2, for instance, I would just need this matrix, right? 1, 0, 0, 1. because this would describe like all my x values, this would describe all my y values, and now I can talk about two-dimensional space, right?
You could also like use like maybe a different vectors. That's what I'm saying, like because those vectors, what you're using, this is called the orthonormal basis.
Sure.
So they're orthogonal to each other and they are normalized.
Because
but you can also say that the matrix A is is 1 1 negative 1 1.
Okay, wait. So you say this also works. So you say 1 1 negative 1 1. This?
Yeah.
Okay.
Yeah, because anything can be written in terms of those.
Right.
Yeah. Anything.
So
can
even
be
though these aren't orthonormal with each other, right? Because 1 negative 1, what that describes like this probably. This is 1 comma negative 1, and then 1 1 describes this. Oh, these are orthonormal to each other, but
they are orthogonal. You can do 1 negative 2 if you want.
Sure, 1 negative 2, right? Yeah, but any combination of these vectors can describe anything in this space. Because I just like take different multiples.
You can see the row reduced version of that would end up with the identity.
Sure. Yeah, if I was to row reduce this, okay.
Yeah, exactly.
Okay,
so that's how.
But this means that there are no extras. Maybe sorry. So if I say like the columns of A span Rn, could there be like superfluous, like like almost like duplicate copies of columns that I don't really need? Like, for instance, in the simple case, if I was describing R2 and F... Oh, but it's always an n by n matrix, I guess, right? That's what we said?
It did say that because all of the columns...
It is n by n. Yeah, it's n by n.
It's also all of the columns of A.
Yeah.
Since they span Rn, that means that there is no left.
Yeah, there's no...
But if it was like an m by n matrix, then you could have leftovers. So
because I'm thinking about this, I could have like 1 0 or like 0 1, and then I could have like 2 2, right?
Yeah,
this is I don't need this. This is superfluous, right? So in this case, I would say that the columns definitely span Rn, but I actually only really need these 2 columns to span Rn. R2, I guess. Yeah. Okay. So if the columns span Rn, then the rank of n, then the rank is equal to n, and n plus nullity has to be equal to n, so nullity equals 0. Cool. July says, you didn't mention AI neural networks. Yes, of course, yes. That's the hot topic, yes. All of AI is linear algebra, 100%. Neural networks, pointing, whatever the fuck, support vectors, all that stuff is linear algebra. Yeah, if you want to do video game design, all the ways they like have the light reflect and like the object detection and whatever, that's all linear algebra. Is nullity the nullity of the kernel? Isn't the dimension nullity A the nullity? Oh.
What was that?
I see what you're saying. Sorry. So nullity A is... Yeah, sorry. When I wrote nullity, JC, when I said the nullity... Sorry, I mean the dimension of the nullity. Sorry, dimension of the nullity is equal to 0. Because then dimension... Yeah, this is shorthand. I know, this is not rigorous, but dimension of rank plus the dimension of the nullity is equal to n. I think the nullity is its own matrix, Rampton, isn't it?
The nullity, so it's called the kernel of A. So the kernel of a matrix is all of the vectors that multiplied by the matrix give you the 0.
I see. Okay. Yeah. Yep.
So if you have like AV equals 0 vector, then all vectors V that satisfy that condition span the kernel of it.
Yes. Span the kernel. Yes. Yeah. So nullity of A is the nullity. Yeah. Not the kernel. X-Man says he does video game design. Oh, that's sick, dude. Use Blender. Oh, nice. To model for people. Yeah, Blender's great. I need to get into Blender. They now have like AI stuff you can use to like create stuff in Blender, which is super sick. But that's like a lot of the mod community uses Blender and stuff. What type of video games do you design for, X-Man? Do you do like indie games or any big AAA franchises? Is there anything useful in taking algebra-based physics if I have to take the calc-based one? Yes. I mean, you will learn everything that you would learn in algebra-based physics in calculus-based physics. So are you asking me, is it a waste of time? I mean, if you can just take the calc-based one right away, yeah, go for it. But if there's some requirement where you have to take the algebra-based one and then the calc-based one, you're still every time you take a class, you're still going to learn stuff. My perfect example for this was in high school. I took AP Calculus, whatever, C, and I got credit for E&M and I got credit for mechanics. I came into college, I wanted to be a physics major, and I couldn't take the next highest physics, which would have been waves, because I needed to take, I think, Calc 3 first. So they're like, you can just not take physics and like get your Calc 3 out and then start taking physics once you've like satisfied the math. Like, I'd advanced too far in physics that my math hadn't advanced far enough for me to take the next physics. But rather than take no physics my first semester of college as a physics major, because I was like, what am I doing here as a physics major if I'm not taking physics? I retook E&M. And I will tell you, like, retaking a class the same way if you like rewatch a show or like rewatch a movie, you pick up on so many more things. You're just like, I learned so much retaking that E&M class. So if you do algebra based and then calc based physics, I guarantee you're still going to learn. You're going to learn a lot more than just taking calc based. Yeah. Okay, let's do the second part question here, Ramton. Determinant A plus B is equal to the determinant of A plus the determinant of B. I think I can just do like a fucking counterexample of this, no? Right?
yeah, because that one's not true also. Yeah, I think I misread it as multiplication first. But yeah, that one's not true. You do a counterexample. I'm pretty sure one of the easiest counterexample is using the matrix 1, 0.
Yeah, I know this one. It's
yeah.
You say A is equal to like 1, 0, 0, 0, like this, right?
Yeah.
And then you say B is equal to I don't know, like 0, 1, 0, 0 maybe.
Yeah.
So no, sorry.
One at the bottom
0, 0, 1. This is what you want, right? Yeah. Because then A plus B would be equal to 1, 0, 0, 1, and the determinant of this is equal to 1, right?
Yeah.
But the determinant of A is equal to 0. The determinant of B is equal to 0. Yeah, okay, cool. And that does not equal 1. So there we go. Cool. Great question there. Appreciate it. Thank you, Ramton, for the support on linear algebra. Nice! Whose was that? Who did we just do? Vincenzo, what's up, big dog? Oh, X-Man, you want to show me some examples of your commissions? Would love to see that. I think this was JHNats. JHNat. Okay, cool. Nice, dude. All right, let's mark that. What's going on, smart people? What's up, clickbait? Good job. What horrendous physics questions are is your teacher asking you this time?
Wait, clickbait's saying what's going on, smart people. Do you watch Andrew Dotson clickbait?
Andrew Dotson? Who's Andrew Dotson?
He used to be a YouTuber. Like, I used to watch him a couple of years ago. He doesn't. But yeah, he started a lot of his videos by what's going on, smart people.
Oh, really?
And he did like both like physics or like math meme videos, and then he also taught like a bunch of like physics, and then he started his PhD like I think 3 or 4 years ago, and then he never posted again after that.
He just disappeared.
Yeah, I think he posted like 3 or 4 in the last like 4 years.
Yeah, it is very interesting to see people like burnout is real, man. Like some people like just they have like a run for things, and then for whatever reason like personal things come up in their lives, or I can't tell you how many times I've thought about quitting just because, you know, either you're getting no viewers or like no response or no positive feedback. I understand totally why people would be like, fuck this, I'm out. But There's always that famous meme, right? What is it? The guy digging for diamonds.
Yeah, I knew exactly.
Fucking love this meme, dude. Yeah, this one. This is always the meme everyone always talks about, dude. Where it's like, don't stop, dude. You were so close to the diamonds. Don't stop. Never quit. Vincenzo says, I got a midterm in 2 days. Geometry and linear algebra. Can I show you something? Yeah, I mean, you can always submit a screenshot of your question if you want me to go over it. So for those that are watching you, because welcome 50 users on YouTube. What's up, guys? We have a website, www.actualofficehours.com. And what you do once you go to that website, you can type in your username. You can drop in a screenshot of a homework question, a practice test question. I don't care. Something you want to learn and have us go through. Hit upload. It'll get uploaded to the queue. And then here's our queue so far. So next question is from I already know what Neptunic's going to ask because he's always asking me engineering questions. Oh, actually not bad. No, this isn't engineering. Well, it's technically engineering, but it's, I'm pretty sure this is actually just torque. Love this. Thank you, Neptunic, for giving me something that doesn't involve, like, I don't know, like stress or strain or whatever the fuck. Weird-ass, like, engineering terms. I do see the TikTok chat. Yeah, I do, MW. Yeah, it's right there. We're on all 3 platforms. We're on TikTok. We're on YouTube. We're on Twitch. Technically, we're also on Discord. Let me see what X-Man said. X-Man was saying he uses linear... He makes things in Blender. Oh, that's sick, dude. Yeah, one sec. I gotta do it on this one, sorry. Nice. That's like a sword? He created like a sword or something. It's like a katana. Oh, wait. Is this the dark sword from fucking Grogu and stuff? You know what I'm talking about? Is that the dark saber from The Mandalorian? I'm a huge Star Wars buff. I should know that. Oh yeah, it's literally in the title.
So nice.
He says that was a dark saber. That's very cool, dude. Sick. All right, this question. Yeah, this one does look interesting, Ram. Right? Oh. Okay.
Is this a static problem?
Yeah, it's so funny. Like, engineering statics is basically just sum of forces equals 0, sum of torques equals 0, except they call them moments.
Yeah. I think I read a thing about why it's called... Or was it you that said why it's called moment?
Yeah, well, someone in my chat has definitely said it. It's the difference between bending versus something. Like
actual twisting versus...
Twisting. Yes, it's twisting versus bending. I think twisting is torque, but bending is moments.
Yeah, I guess. But
yeah, and then people are getting mad at me because I use this for torque. I say this is my symbol for torque.
Oh, okay.
People just they don't like the gamma. I'm just like, is that right?
Looks like the Christoffel symbols.
Dude, it's gamma, dude. It's gamma's torque.
Wait, do you not use tau?
I don't know who like set me up for failure in life in my physics career, but I learned this at some point and I've never let it go. And that's what I use for torque. I agree it's tau. I know torque is supposed to be this, but I don't know. By the way,
my taus I feel like look decent.
Yeah, this is my tau. It's okay. All right. Solve for EY, solve for EX. I feel like, and wait, and I have FIG, and I have FJK. Well, that's cool. And wait, what's this 30 degrees? Is there something else attached here, or is this just like a coordinate reference? Okay. So I mean, the interesting thing here, I think if you, and they don't give you any distances, right? It's just coordinates. So, I mean, correct me if I'm wrong, but if you set this as your rotation point, then sum of torques only cares about this and this. And you assume that the sum of those torques are equal to 0, right? Which I guess they must be. Because these things act at the rotation point, so they don't contribute to the torque. So I don't even think you need to do sum of torque here. I think this is literally sum of forces equals 0. because we can just break down these forces into components, and then we know the sum of the x forces has to oppose this, and some of the y forces has to oppose this. I think so. Let's see. Okay. Well, if this is 30 degrees, then that means like this angle's 30 degrees as well. I think so. Oops.
Yes.
Well,
What's up,
to
Ethan?
say something really quick.
What's up,
So,
dog?
about that take-home test. Yeah, I'm about to initiate that. I'm
Yes.
looking at the flyer that the professor posted.
Yeah.
She said that this is going to be 30 questions in 45 minutes. And
Okay.
I can't switch tabs. It's going to monitor my screen. So I just have
Yes.
to use the notes app. I'll have my phone beside me so
There
I
you
can
go.
at least
You can cheese it a little bit. Yeah, dude. All these like whatever online tutoring proctor things, they're all garbage, dude. You can get past them. But you should always try to do things yourself because that's the only way to learn. You know.
Yeah, I guess you could say so, but at the same time, I just want to get.
I just want to pass. This is always the temptation, though.
Like seriously, it's like this is the golden opportunity. I haven't had a take-home test in like.
Yeah.
Forever.
Trust me, bro. Everybody else is doing the same thing. This is why when I give take-home tests as a professor, I tell them they can use whatever the fuck they want. I say it's open whatever, because even if I told you it wasn't, you'd still do it anyways, and that only punishes people who are being honest. So I make it open. I make it open whatever, but I say you can't use AI, and I can tell if you use AI, because I designed the questions so that like you will fuck up in certain ways if you use AI.
Well, hey, the thing is that it's like it's a golden opportunity. I'm passing the class with like I'm passing the class with a 93, and when I tell people I'm failing, they don't even believe me because it's like I don't know how.
Yeah, you can't fail.
But like I'm telling them I'm failing and I have 93, yet they say that doesn't know what fail. Like you know those people that always say that, but then they know it's not true. That's me right there.
Yeah. No, this is a classic thing, especially in like the pre-med student groups. They'll always be like, oh my god, I absolutely failed that test, and then they get like a 97 on it. They do it just because I don't know, they're trying to like psych each other out. It's really actually weird. They're like, I don't know why they do it, but
I think I know why, but then at the same time it just when I state my answer, I'm just contradicting myself.
Yeah.
I'm about to initiate the take-home quiz.
All right, do
I'm
it.
going to have
Good
to
luck.
mute the site though, so I'm going to have to mute this Discord site.
That's okay.
So
You can totally mute it, dude. You're good.
45 minutes I got for 30 questions. I hope I get 100. And people still somehow manage to fail this, even though it's take-home. I don't know
you'll
how.
do well, dude. I trust in you, dude. I'm gonna send you all my smart prayers.
All right then. But I'm about to initiate it. So
All right, do it, dude.
See you.
Good luck. Good luck, Ethan.
Okay.
What is Drew? I think you're on the right case. You're on the right idea, Drew. Wait, E cosine 30 plus E sine 30 plus FIG equals F? Sorry, what? Where the fuck are you getting this from? Dude, what? Where's the other F, Drew? I love how engineering dumbs everything down. Dude, yeah, I was saying this the other day. Like, engineering is physics with a condom. Like, they just make everything all safe, and like, they're like, oh, we have all these like cute little tables and like, heat of vaporization for steam and water, and I'm just like, oh man, stop. Like, just do the physics. Okay. So I think we're good here, right? Because then I know that if this is supposedly in equilibrium, right, that the sum of the forces in the x direction, we had a very different, he's like, my physics was not nice to me. Sum of forces in the x direction is equal to 0, so that's going to be FIG cosine 30 degrees, right, because that one's pointing to the right, plus EX, and then it's minus FJK cosine 30 degrees. This all has equal to 0. And then in the y direction, FJK sine 30 degrees minus FIG sine 30 degrees. Wow, thanks for the raid. Academy of Useless Ideas. What useless ideas were you going over today? Tell us. Sine of 30 degrees. And then this is minus EY has to be equal to 0. Okay, cool. Done. What's up, home dog? Femvox, the solutions manual has arrived.
Perfect.
What was going on? Da-da-da. You got an 8% on your fluids exam, Burrito? Damn. I'm trying to think the lowest grade I ever got in an exam in my college career. I know the lowest grade I ever got. I got a B- in quantum once. That was definitely like the lowest grade ever on my transcript. This looks like some statics. It is. Yes. Or as I like to say in physics, it's just torque. In this case, it's actually just Newton's second law, I think. Oh, wow. Thanks for the follow, Academy. You weren't following me, dude? I've been following you for a while. Shame. You're okay. Yeah, first he must have curved it then, right? Had to have. Okay. Hey, those two loads are parallel. They are parallel. Well, is there a trick to this Fembox that I should know about? Parallel loads? Sounds like an album title idea. Parallel loads. Okay. So just subtract them and that's your resultant at E? Oh, yeah. I mean, that's what we did, essentially. See, this is what I'm talking about. Like, engineering just comes up with, like, cute little tricks and rules that it's just basic math. Like, yes, if you subtract them, which is essentially doing sum of forces is equal to 0, correct. You get EX. But it's cute that they say, like, oh, if the loads are parallel, then da-da-da-da-da. And I'm like, all right, man. Yes, the reason why, and this is actually really, yes, and then do a 30, 60, 90 to get the components. Yeah, exactly. Yeah, I get it. Yeah. Well, I'm going to do it the way physics taught me to do it. The way the King James Bible of science said that we should be doing science, which is, I did a sum of forces. FIG was, dude, what in God's name are these numbers, though? 5406? Like, why? Who picked that number? I guess they needed weird numbers because they need the sum of the torques to be equal to 0. You weren't cool enough to be your friend. You're cool enough now, Academy. You're cool, dude. Okay. Cosine 30, and then minus 96, 93. It is statics. Yep, mystical. We're doing statics. Cosine of 30. Okay, cool. And then the negative of that is EX, right? So then EX is equal to 3712. So EX is equal to 3712 newtons. You're cool. Yeah. My friends used to always joke with me that, like, everything I do, I was just trying to be cool. And I was like, what happens when I actually become cool, though? Do you guys have to stop making fun of me for it? Someone told me the other day, you're the coolest person I know. I was like, oh, wow. I've made it.
I mean, you're a DJ. I feel like, based on the stuff I've seen from you, you hold up to the title for sure.
Right. Thank you, dude. Yeah. I think some people just get jealous because they're not cool. And they would rather just, like, tell me that I'm doing it because I'm trying to be cool. And I'm like, okay. Well, how about you just become cool as well? All right, thanks. Thank you, Playmo for coming in. I do need to drink some water. Okay, so then the answer for this is 2144 newtons. Yeah, there we go. EY equals 2414. We finally have a government today? Yeah, wait, did they reopen the government? Is that real?
There is a little bit of a political situation happening.
Is there a hiccup? Is there a hiccup now?
Well, some of the Democrats that were like, hey, if you like
promise we're gonna vote on healthcare.
If you promise to like vote, then we'll for you. So it's kind of like
ugh. I have this whole theory that they only held out the shutdown as long as they did for the November elections to happen. Because Democrats at least have to show they have some fucking spine for doing something. You know, so it's all a game. And in the end, we all just lose. That's how this works.
Yeah.
Yes. If you pinky promise, it'll be okay. Yeah, I know. Yeah, whatever. I mean, yeah, dude, it's something actually very near and dear to me because I just got the notice in the mail that my insurance premium is gonna like fucking double next year. Because I am one of those people who's on ACA credited healthcare because I'm not employed. I'm self-employed, and self-employed people don't have a nice company to pay for their insurance. I have to pay for my health insurance, and it's fucking expensive. So, yeah, I agree with the Democrats trying to like stop things, be like, yo, let's like not let these credits run out because my life's about to get a lot more expensive if they do, and I really don't want them to be. And I'm not like some freeloading illegal immigrant that the fucking Republicans claim are all using it. No, I'm just a normal person just trying to teach kids math and science on YouTube. And like also have health insurance.
Yeah,
anyways.
Definitely.
You have health insurance, Ramton, though, because you're in Canada.
Yeah.
Isn't that nice?
We have a bare minimum kind of like. I mean, it's free.
But if you're fucked, like you don't go bankrupt. Like if you get cancer, they will take care of you. In the U.S. here, if you have cancer and you don't have health insurance, you might as well kill yourself because it's either that or JP Morgan will.
Yeah, in here it's like if things are really bad, like I don't know, it's kind of like you have to do a lot for your condition taken seriously.
Yes.
But I mean,
like the wait list for like for regular care, I get it. In Canada is insane. Like if you're trying to get I don't know, like you have back pain and you're like, I really want to get this back pain looked at. It's not going to happen unless you again get private health insurance and pay for it. But the upside is, yeah, if something's gonna kill you, they make sure you get help. Yeah,
it's good in that sense.
Yeah.
All right, sorry, I gotta go teach, but I'll try to hop back in. If not, I'll see you maybe tomorrow or Wednesday.
Yeah, all good. We'll be here tomorrow. Good luck with teaching, Ramton. Thanks for your help.
Thank you. Yeah, thank you.
Peace.
All right. Peace out.
Bro, that quantum lecture was bonkers. I'm happy to see forces. I'm happy too. By the way, thank you, Neptunic. We finished your question. Good job. Good job. Academy says, that sucks. The worst part is that not even the companies pay much for it here. It's more the negotiation. Yeah. Yeah. Dude, everything's a mess. I just want to do physics. And, like, teach math and science on YouTube. Like, I don't want to have to argue with like insurance agents and like premiums and like blah blah blah. Like, can y'all just like play nice, please? I do know integrals for Insta. Yeah, that's a really cool website. Those that don't know about it, it's daily integrals, right? Is it called daily? Let's go to Instagram. That's my Instagram, but what is it? Integrals. Daily integrals. I think something like this. Integrals for you. Is it this one? Yeah, this one's not as big. Integrals for you. Okay, let's go find it. Yes. Yeah, this is it. Yeah, so this is a very cool website. For you guys that are in calculus, they have an awesome, look, useful formulas. These are great. These are really great. Like, their pinned posts at the top are really great references to have. They have like tables too. Yeah, these are really dope too. But then every day they post like a hard integral, and then I think they post the solution to it, right? Or have they? Do they take a while to post the solution? This one has the solution. That's your challenge? The cubed root of tangent. Yeah. Wait, there's no solution for this one posted yet. It's easy but unreal result. Okay, cool. Yeah, so they do a bunch of them. So if you want to just get good at calculus, I highly recommend, like, if you're following anything on Instagram, like, unfollow, like, Kim Kardashian. Go follow this shit. It'll help you out a lot more than, like, I don't know, learning, like, what, like, body shaper you should be buying or something. But they have like, detailed breakdowns on the solutions and stuff. Oh, this is a challenge. Oh. Okay, I see. So this one doesn't... So the challenge ones, they don't post the solutions for. I love blitzing statics, yeah. What is the basis I need to start learning calculus? Pre-calculus, Anthony. Another somebody, sorry. Yeah. Pre-calculus is great. Where do you start? Oh, okay, so here's a great way. So it depends like what level of math you know, somebody. So I think having a core foundation and knowing, right, algebra, a little bit of trig really helps. How to manipulate variables. If you at least know all that stuff, then you can kind of jump right into calculus. If you don't, then yeah, please join my Discord. I'm going to be announcing a course pretty soon here, totally free to you guys, that I gave to my first week of when I was teaching at UCLA for my physics class, because I wanted to make sure everyone in the class at least had enough foundational math knowledge to do physics. And it's the same foundational math knowledge you need to start learning calculus. So go to the website, join Discord, look out for an announcement. I'm going to do it either at the end of this week or next. I'm wrapping up some like structural agreements because I'm hosting it on another like company's website, and I have to like cut like a payment deal to them or something, but I'll figure it out. You were in my YouTube doom scrolling. Yeah, that's another great way. Yeah, doom scroll more on my stuff and you'll learn. All right, let's see. Next question comes from Hi. Looks like a calculus question. At what level is multivariable useful? In everything, dude. What? Multivariable is super useful. Because, surprise, the world is like multivariable. Things in life don't depend on just one thing. They depend on a lot of things. So being able to determine how things change, what the maximums for things are in many different dimensions with lots of different variables, that's all multivariable calculus. Big ups to the algorithm. Yeah, she's doing good sometimes. Entanglement will be the future of communications. I maybe. That's gonna be kind of weird then, because then isn't the answer like yes or no at the same time, or like the answer is yes until somebody else says no? That's like entanglement. The states are entangled. Do you use trig sub? All right, they tell us right away just to use the substitution. E to the x is equal to tan u to show that. The integral of square root of 1 plus e to the 2x is equal to that. I love how they say cosec instead of just like cosec. The world is just one variable, dude. Either things happen or they don't. It's my way or the highway, dude. Okay, so if e to the x is equal to tangent of u, and then okay, let's talk about like what e to the 2x is. Well, e to the 2x is the same thing as e to the x squared, right? This is, again, you ask me another like what do I need to know to start learning calculus? You need to know that this is a rule. This is a key exponent rule, that if you don't know this, then this is where we need to start. You gotta learn this stuff, because otherwise it's like trying to build a car but you don't understand how a screwdriver works. You gotta have the tools. So yeah, so this means that e to the x squared is tangent squared of u, but then we know that tangent squared of u, there's an identity for this. Again, this is a pre-calc thing, which is that 1 plus tangent squared u is equal to secant squared u, right? Oh, and then yeah, also I have to do something else. One sec. If e to the x is equal to tangent of u, I also need to come up for an expression for dx. So this is where I'm going to do the derivative of both sides. So down here, right? This means that d e to the x is equal to d tan u. But d e to the x, that's just e to the x dx. And then d tan u, so the derivative of tangent is secant squared. So this is secant squared u du. And so, sure, dx is equal to secant squared u du. Or do I want to do this in terms of ln over e to the x, but then e to the x is equal to tan u? I think I can. I think this works as well. Okay, so then let's write out what this integral is. So this is now the integral of the square root of 1 plus tangent squared u And then dx is now secant squared u du over tangent of u. 1 plus tangent squared is secant squared. Yes, linear equations are great. Again, somebody join my Discord. I will give you a course for like learning the basics in like a week. But you'll get notified about it if you have Discord. I highly recommend getting Discord. Discord's great. Exactly. You know none of this? That's totally okay. Good. Awesome.
Yeah.
I will make a big announcement when I open it up. Because you're not the first person to ask me this. I've had a couple people ask me just even over the last couple streams being like, hey, how do I get involved with this? And I have something. I've already written it. I gave it to like my students at UCLA. That's like what I used. So, and I know it works. Yeah, of course, dude. Appreciate you too, man. Yeah. All right, so this is secant u, secant squared u du over tangent of u. Am I trying to get to like secant to the third? Oh dear. I do not have a course for, well, I mean, if you want to go learn E&M, you can literally go do it on YouTube. All my lectures are recorded. Over the summer, I taught a summer class, an online summer class at UCLA. So if you go to like my courses here, here it is, Physics 1B. This is E&M physics at UCLA, and there's 25 lectures, and they're all about an hour and a half long. So if you literally want to go through my class, you can go watch this if you really want to. You won't have access to the textbook. That's what you got to pay for. But you can at least like watch me teach. Okay, so this is integral of secant to the third u du over tangent of u. I'm trying to get to like secant squared and cosecant. So I'm gonna pull this I'm gonna pull the secant squared out. So we're gonna say secant squared. Well, actually, that's what I already had here. It's like actually, sorry. Let's not waste digital paper here. I already have the secant squared part. We just need to look at this. Now, here's a cool thing. Again, and this is something that you will learn if you do some basic trig, is that secant of u is equal to 1 over cosine of u. And then tangent of u is equal to sine over cosine u. So this divided by this is the same thing as 1 over cosine of u times cosine of u over sine of u. Which, yes, this cancels. And so you just get 1 over sine of u, but 1 over sine of u is equal to cosecant of u. Okay, cool. So we've now proven that this is cosecant of u, secant squared u, du. Nice. Hey, man, I'm in biomed. Any advice on getting into pure maths? You did higher level math in high school? Great. I'm not the best at pure maths, but I have a lot of friends who are. So again, if you're just joining us because you found us doom scrolling or you found us on the algorithm, there's a website here that we used. What's happening? Students are submitting screenshots of questions, and I'm going through them on the stream live. The website is actualofficehours.com. You can drop in a screenshot of your question, get help. But also, what I wanted to point out to you, Joseph, is that if you click here on streaming schedule, we have a calendar, because I'm not the only person that does this. There's a whole other like team of partners and friends who also do like math and science streaming. Nice. And some of them are even like professors, like chairs of professors in math at different universities. One example of that is Penn Center here, who is going to be running a data science course after my stream. And so you could ask him about getting into pure math. Or Zach tomorrow morning has a PhD in math, and he's on Twitch on this address as well. Bro, I just jump scared. A calendar. Yeah, well, shout out to Zach. Yeah, there you go. So yeah, Zach is an example of someone you could ask about how to get into pure math. I don't personally know much about pure math. It scares me. But yeah, go to that website, go to the streaming calendar, click on e to the 2i pi, or click on Penn Center on the calendar, and go follow them on Twitch. And you'll see them. All right, let's do this. Determine the perimeter. Wait, is this a separate question? Are these questions related? I'm curious. Wait, what? So I figured out this integral, but then it says determine the perimeter of the region bounded by. It scares me too. I thought since I can do chemistry equations, I'd be able to do calculus. I was wrong. Yeah, chemistry is chemistry does have math, and it is one of my other favorite subjects to teach. It's unfortunately the math they use is pretty basic. Unless you get into like, I mean, Joseph, JC can probably talk about this. Like PChem, I think starts getting into like quantum mechanics, and like maybe there's some like more advanced math you use. Okay, let me see this. I'm curious. These seem like two detached questions. Y equals e to the ax. Y is equal to 0, x is equal to 0. Okay, so we got some regions at least. So we got to be over here. We got to be over here. And for extra points, why not just evaluate this integral? I don't really want to. Lagrange, square root d squared y plus 1 integrate. So wait, Jeff, is this related to what we just did? That's what I'm curious about. Oh, you know why it is? Oh, motherfucker. I think I know what it is. That's arc length, correct? Yeah, I know what he's talking about. Okay. Right, okay. So if you integrate... Yep. What's it, from like x0 to x1? The square root of 1 plus f prime of x squared dx. This is the same thing as perimeter, which is equal to perimeter. It's really equal to arc length is what it is, but the length of an arc is also the perimeter. It is by the Pythagorean theorem. Yep. There's a cool little demonstration for why this is. Okay. So yeah, if e to the ax is equal to that, then wait, then okay, so f of x equals e to the ax. Wait, f prime of x is equal to a e to the ax, right? So f prime of x squared, there's gonna be another a squared in there, no? That's a squared e to the 2ax, right? Jeff says no. Oh, I am right? Fuck. We hate it when I'm right. Well, I mean, we can still kind of use this same terminology here, right? Because what do we say? Jeff is wrong. Jeff is not wrong a lot. I mean, we're just gonna get a little sneakier. Yeah. Oh wait, where's that? Sorry. What was it? E to the x equals tan u. So, in this case, it's e to the ax, right? Yes. E to the ax is equal to tan u. But man, that a squared is gonna kind of fuck with me, dude. I don't really want that. And also additionally, wow, they're saying x is equal to b, which is greater than 0. Raw, why'd you say Lagrange? I'm curious why you said Lagrange. Is that like a thing? Am I supposed to actually use Lagrangians here? Because then what does that mean dx is equal to? Yeah, so now this thing doesn't really work out as well as I wanted it to. Because I have the a squared in there, right? Oh, actually, no. It's fine. It's fine, right? No, wait, it's not fine. Yeah, the a here, right? What? The a messes this up. Okay, let's just do it again. It shouldn't be an issue. I have a feeling it's going to be, though. Because if e to the ax is equal to tan u, right? Then, a e to the x dx is equal to, like, secant squared u du, right? This is already, like, changing things. So, dx is equal to, secant squared u du over a e to the x, right? But e to the x is equal to, or e to the ax, sorry. E to the ax. And e to the ax is tan u. Yep, no, you're right. Tangent u, okay. So now I have the integral of the square root of 1 plus... Oh. No, I think I just say this. I'm gonna say, I think I'm gonna say this. No, fuck, it doesn't really work. Yes, no, yes. E to the x squared. Yeah, I think this is what I say. Yeah? So then I get a squared. A squared. Because at the end of the day, I'm trying to do the integral. I'm trying to do this integral. This is going to be a e to the ax squared, right? Oh, okay, so I think this is fine, actually. Right? Because f prime of x is equal to a e to the ax. And we're doing that squared. So... And then this is still 1 plus tangent squared of u. Oh, but okay, wait. Oh, but it's just a constant. Okay. No, that's okay. Yeah. We're just pulling out a 1 over a squared. Okay. Okay. So this is the only thing that changes on what we did here. I think we just divide by a squared. Right? Okay. Okay, so this is equal to 1 over a squared. We'll figure out the bounds later. And then it's secant squared u cosecant u du. And now we have to do the integral. Oh no. Secant is 1 over cosine. Cosecant is 1 over sine. Some things we know. So, d du of secant u is equal to secant u tangent of u. And then, because it's a shame this isn't like sine squared cosine. Because then you say u is equal to sine, and it's u squared du. But it's not. Cosine squared u. 1 over sine of u du. Does that help us out? Okay, what if we say... I need a different variable now. I'm running out of variables. Let's say... No, I don't want to use... Yeah. Let's use z. Right? Let's say... Cosine of u is equal to z. So then... dz is equal to... negative... sine of u du. Okay, and then let's try to like replace some stuff here, right? So this is the same thing as z to the minus 2. I have du over sine u though. Oh wait, whoa. Wait. No. Damn it. Yeah, wait. So then I get du is equal to dz over negative sine u. Oh, that just makes things worse. Oh, wait a minute. I think I see where this comes in. Okay. So now this is dz over negative sine squared u. No, I think this is probably where it's coming from. Right, because, wait, negative sine squared u, right, because sine squared plus cosine squared equals 1. So cosine squared minus 1 is equal to negative sine squared. So, I don't know, this is getting kind of wacky. 1 over a squared integral z to the minus 2 dz. But then this is all over cosine squared u minus 1. But cosine of u is equal to z. So this is now 1 over a squared integral z to the minus 2 over z squared minus 1 dz. Right? Is that solvable? Or we just multiply that in through. Wait, so that's 1 over a squared. Integral of 1 over z to the 4th minus z squared dz. Am I gonna end up doing partial fractions? That's a pain in the ass, dude. 1 over z squared minus 1. I think it is. 1 over z squared, z plus 1, z minus 1? Really? And then do I need to partial fractions this? So this is, what's the Laplace transform used for? Doing stuff in like different domains. Like sometimes integrals are easier to do once they've been put into like Laplace. Keegan says I did it wrong. Thank you, Keegan. Where do you think I did it wrong? What did I do wrong? Originally we were just right here. This is me like going down kind of a nonsense land, trying to see a way. I see it's partial fractions maybe. But Jeff says, is there a secant squared tangent squared identity? There is. 1 plus secant squared is equal to tangent squared. Or sorry, 1 plus tangent squared is equal to secant squared. Which maybe that's where this comes in from, because then it's just integral of cosecant, and then it's tangent squared cosecant. Cosecant's 1 over sine. Gold, I'm a coffee addict. I love coffee, famished. I'm an Americano fiend. It's z squared. The whole function isn't squared in the end. What? Where are we getting that from? Sorry. All right. Let's see if there's an easier thing for doing secant cosecant. And actually, I'm gonna cheat a little bit. I'm gonna Wolfram. Integrate. What was it? Yeah, probably does, honestly. Secant squared cosecant of u. Dude, if someone suggests the Weierstraub, dude, no, don't do that to me. Okay, well, apparently it's pretty ugly. And it uses half integrals and logarithms. Okay. Right, secant squared, cosecant squared of x. Cosecant squared. I do have Wolfram Pro. Man, I just don't have it on this computer. I have it on my mobile. Fine. I'm going to chat. I just want to see what the technique is. If it's converting it to tangent... I just want to see what it comes up with. Right, that gives me 1 over sine cosine squared, but I think about substitution. It turns into a rather messy integral. Yeah, involving that. I agree. Oh. It's integration by parts. Oh, that's so cool. Okay. I didn't even think about that. Alright, so screw this. This was a valiant attempt. And then, sorry, what did they, which one did they pick? They picked u to be cosecant. Okay, so u is equal to cosecant of u. dv is equal to secant. Well, this is an issue. Oh, we have, because we have u's and v's now. Oh no. Okay, I'm gonna make this like secant squared of z. Sorry, because I need the u's and v's for integration. Yeah, it's integration by parts, Zach, apparently. I wouldn't have seen that. Would you have seen that, Zach? Would you have immediately seen that this is an integration by parts question? You can do U sub. Use cursive U and V. I'm using Z. Well, that's what we did, Anch. We did sines and cosines. It was not turning out very nice. And multiply, divide by sine? If you want to show me, Anch, you want to write something up and dump it? I'd love to see it. So this is negative. So derivative of cosecant is negative cosecant cotangent, right? Right? And then this is dz. And then, yeah, that's what I was doing, Anch. I was doing that. Wait, what's the integral of secant of x? Oh, the integral of secant of x is ln secant x plus tangent x? I really don't want to integrate ln, dude. Wait, whoa. Du is negative cosecant cotangent. Oh, secant squared. Oh, yeah, dude, I'm so dumb. Okay, yeah, duh. Sorry, I forgot the squared. Got it. Okay. No, but we're integrating secant squared. This is just tangent of z. Very cool. Okay, so then by u sub, it's equal to... Yes, that's what I had. No, I had that, Anch. I did. So this is cosecant z, tangent of z, minus integral of v to u. So this is negative cosecant cotangent cosecant z. Yep, that's what I was doing, Anch. Yeah, I didn't want to do the partial fractions, though. It was looking ugly. This might be cleaner. Because I think once we're here, this is probably sine and cosine land, right? Because this is negative 1 over sine. Cosine over sine. Sine over cosine. Right? These cancel, right? dz. So then it's just literally the integral. So it's cosecant z tangent of z plus the integral of cosecant of z dz, and then cosecant... Oh, sorry, I need the integral of cosecant. Okay, cosecant z, tangent of z, plus or minus ln of cosecant z plus cotangent of z. Great. And then this was all 1 over a squared. And then u... Sorry, and then we said a e to the x was tangent of z. Yep. Cosecant tangent is just secant. Agree? Yep, because this is 1 over sine. This is sine over cosine. Very good. Good call there, Anch. This is 1 over cosine, which is just secant. So secant of z. Minus that. But ae to the ax was equal to tangent of z, is what we said. Okay. So do I have to build a triangle then? So opposite over adjacent. So this is a e to the ax. This is 1. So then this is the square root of 1 plus a squared e to the ax, right? If this is angle z. So we get 1 over a squared. Secant of z is 1 over cosine. So it's hypotenuse over adjacent. So square root of 1 plus a squared e to the ax. E to the 2ax, sorry. Over 1. Minus the ln. Cosecant is going to be square root of 1 plus a squared e to the 2ax over a e to the ax plus cotangent, which is just going to be 1 over a, or just, yeah, 1 over a e to the negative ax. Great. How does that answer the original question? Determine the perimeter, dude. Dude, what the shit? Is this the answer? What's up, Ethan, dude?
Bro, I'm sorry for the interruptions, man. I'm really sorry.
What's up, dude?
Bro, I'm telling you, I just did that take-home test.
How'd it go?
It was 30 questions and 45 minutes. I took literally all the time, and I submitted like somewhere near the last second. The only thing that like had me questioning was like 2 questions. Like, I mean, it was not explicitly stated, so I decided to use ChatGPT. But then on other sites, it was giving off different answers for one of them. So it's like it was a kind of a conflict between the two. And when
you gotta go with your gut.
Yeah. So you know what I did? What my gut said? It said go for the first answer, and I just chose the first answer. I didn't know if it's correct.
Oh, nice. Oh, thanks, Demi, by the way. Demi says I got an 85 on my Calc 2 test. Thank you for the questions, for the help, bro. Yeah, of course, Demi.
Yeah,
sorry, what's up? What's up?
It's okay, but yeah. The teacher can view my screen, so I don't know if I get paid. He said it was take home, so I think I can argue correctly. I mean, I have spent a suspicious amount of time on one question.
That's okay.
But I believe that the professor could make it slide. It's just I don't even know if I'll get 100. You know, I think I'll get like
As long as you did your best, dude.
Yeah, I did. Okay.
Nice.
I think. Oh wait, I forgot to tell you. I forgot to tell you. You remember the good grades has been happening?
Yeah.
Oh my gosh, I really haven't been keeping track of that.
Submit a screenshot, Will.
Listen,
yeah, submit your grades. Submit your grades.
Listen, man, I forgot to tell you. I was supposed to submit this by last month, and I kept telling myself I was going to do it, but then of course it never happened. But I took a test. I took a math test specifically. And to be honest, I almost didn't finish it in time, but I did. And then when I thought I wouldn't have gotten max points, I did. And I even broke the limits of a 100. I got 116. Nice. I could show you, but that's from last month. So to make that up,
yeah, just show me something from this month.
Yeah, to make that up, I'm getting a math test Thursday, I believe.
Okay.
Yeah, Thursday. So I don't think I can ask you a question on Wednesday because I got a job, remember? So, but I will try my best. I will try my best on that test so that I can submit it to you. And I have my midterm report card to show you, which
good.
It's not bad, but
yeah, dude. What's up, Penn Center? Pen's saying Ethan the OG, dude. Yeah, shout out to Penn, dude. Thanks for coming by, Penn. Penn's got a stream on an hour and 20 minutes after this. He's gonna help out doing some data science and maybe answering some other questions. Dude, this ChatGPT says I feel like I'm finally on the right track. Come on, chat. This is a horrendous question. I think we did it the right way though, but the answer I got is like kind of sussy. It's like this. Yo, Actual, what's a tip you have for people in their undergraduate looking to go to higher education or graduate school? Don't. No, okay, no. I mean, all jokes aside. If you want to go to grad school, especially if it's in STEM, a thing to do during your undergrad is to get involved with research. So, I don't know, what type of grad school do you want to go to, Faizan? You want to go to math grad school? Is that what you want to pursue? I forget what you're in, what type of field. But in general, yeah, okay, cool, math grad school. So, yeah, in general, with all graduate degrees, it's less about taking classes and it's more about doing research. So getting yourself familiar with helping out with research as an undergraduate is a great way to prepare yourself for being able to do well in graduate school. You do need good grades as well. So for sure, there are things like the subject GRE tests you have to take, and you have to score a certain amount in order to... thanks, Will, for submitting. I see it. For being able to get accepted. But in general, trying to get involved with research early on is a golden ticket for getting into grad school. Yeah. Just bombed my Physics 1 midterm. I'm sorry, dude. No. It's okay. You still have the final. Yeah. If you want to know specifically, again, so I went to physics grad school. So I think it's similar for math. I'll let my other math PhD friends chime in here. So Penn, for instance, has probably sat on like admissions boards, I'm guessing, for maybe some math grad students. Or Zach just recently got his PhD in math this year, I think. Was it this year or was it last year? When did Dr. E to the 2i pi become Dr. E to the 2i pi? Do you know perfect number? I don't know perfect. What the perfect number? Isn't it 67?
That's dope.
You kids. All right, here we go. All right, this tried to do it. All right, the perimeter is the... Oh, look at this. Look at this. We forgot that it's the perimeter plus the two sides plus the arc length from 0 to b. Yeah, and this integral is ugly as sin. Yeah, look at this. Dude, ew. Ew. Oh, man. Okay. Oh, it's sum of factors? Okay. So, yeah. So the perimeter...
Yeah. What the hell, dude? What the hell? X is equal to B? Yeah. Baby voice 6-7. Okay. Alright. This is at least the arc length. I think we got a similar answer to them. This looks pretty similar to what this is. I want to say it is. Maybe it's not.
Yeah, and the last term is the arc length of the exponential curve. Okay. Cool. B plus 1 plus e to the AB. Clip. I don't have that set up yet. Yes, I know a lot about taking the SAT, for sure. And if you want to do well in the SAT, I actually have a couple like TikTok videos that are... That was like calculus from hell, dude. It's technically calculus, but I mean, I don't know. But yeah, if you go to my TikTok, I have a couple of videos about taking the SAT, at least the math section. Yeah, so this one, like 4 equations to memorize for the SAT. This kind of goes over some things that can really help you answer questions quick. And then also, this one's like how to speed run the SAT. Just some like fun little tips for how to get through the questions quickly. And get them correct. And get great scores. So go check that out. It's on TikTok. I'm going to mark this question as done. Because I don't want to work with it anymore. And I think we've demonstrated. So good job, Hi. Yes, I do have a YouTube. Yeah. Just look up Actual Education on YouTube. I have tons of physics videos as well on YouTube. YouTube will strike it. Me opening my own videos? Why? I can't open my own videos on YouTube? They're mine. It's like when someone said like, oh, you should like put your music on. But I'm like, I might get struck for copyright even though it's like mine. It's happened to a lot of people. I don't understand why like YouTube would get mad at me opening my own videos on YouTube, but whatever. All right, cool. Good question here. Hi. I'm gonna download what we did. And I'll also I'll post the ChatGPT solution for you as well. So yeah, I'm posting all the answers to all these questions in our Discord. So if you join our Discord, you'll be able to see your question that was asked, what the answer for was, and then any other discussions that other people have about it. I'm increasing views unethically. Oh. Well, fuck them, dude. What? No, I'm ethically trying to show students how to, like, get help. Oh, you got the baby oh, you clipped it? Thank you, dude. All right. Let's go to the next question. 12B, please, they say. Prove each identity, state any restrictions. This looks fun. This looks fun. Little trig. Nice, you just followed me? Thank you for the follow. S719879. You want to tell us the significance of your number? Okay. Sine squared minus cosine squared minus tangent squared of alpha is equal to this. Okay. Step 1. Divide by cosine squared. Yeah, that actually does work. Does watching your live stream count as study? Yeah. Yeah, it definitely counts as study. The best studying, though, is doing questions. So, yeah. Sorry, multiply and divide by cosine squared. Yeah, okay. I agree. And I see why Anch is saying this, because you want to get 1 minus sine squared on the bottom. And the only way to get that is to have a cosine squared, which then you're going to convert to 1 minus cosine squared. So yeah, let's do that. I agree, Anch. That's a good first step. Great first step. These are fun. These are fun little puzzles. We're trying to turn this into this. So by inspection, you can kind of look at this and inspect what you think you're trying to get and start doing shit to this side to make it look like that. So Anch had a great idea of like, let's just multiply the top and the bottom by cosine squared alpha. Right? And let's see what we get. So doing that, I'm going to get cosine... I'm going to use x instead of alpha, because fuck drawing alphas. It takes too much time. Sine squared x minus cosine to the 4th x minus tangent squared x cosine squared x. Yeah. I just solved the PDE and did linear algebra, and I'm not confused what class this person is taking. This is probably pre-calc. Yes, we'll get there. Okay, and so then this is cosine squared x, and then the cool little assumption we make here is that sine squared x plus cosine squared x is equal to 1. So cosine squared x is equal to 1 minus sine squared x. So I can substitute that in right away. Okay, and then there's some cool things here. So, we want everything only in terms of sine squared. So I'm going to replace that with this one as well. Okay? So then I have 1 minus sine squared x minus cosine to the 4th x. And then this is a cool thing. This is minus sine squared x over cosine squared x. That's what tangent squared is. And then this is cosine squared x. These cancel. What's up, Scrimblow? What's cracking, dog? Good to see you. Okay, so let's see what we got. So now we have sine squared x minus sine to the 4th x. Oh, I don't like the cosine. I need to write that as well as something. Wait, so, is this ooh, actually, you know what? I'm gonna leave that. I think this will turn into something nice. Minus sine squared x all over 1 minus sine squared x. The cool thing here is that this part right here, this is the same thing as negative sine to the 4th x plus cosine to the 4th x. Right? Oh, man. It's almost sine squared plus cosine squared, but it's sine to the 4th plus cosine to the 4th.
Surprise, motherfucker.
Damn. Okay, never mind. I thought it'd be something cool. I was getting excited. Alright, cosine to the 4th x is equal to 1 minus sine squared squared. It's just very meshy.
I don't feel like asking my question tonight, to be honest.
Okay, that's all good, dude.
To enjoy my life.
Yeah, enjoy your life, dude. Go play some Mario Kart.
Mario Kart is not the thing right now. The thing right now is just trying to get through school and whatever I have to offer. But yeah,
No.
I think I'll initiate the plan soon with like writing down those fill in the blank questions and short answers so that I can help process my information. Even if I show it to the teacher and she doesn't, and like you said before, the worst she could say is no. She won't punish me for it, of course.
She won't punish you.
Even if that, even if she does say no, the least I can earn is like understanding the concept at least. Like just for
Yes.
theoretical, but not for
You
practical.
you always gain the knowledge, dude. The knowledge is infinite. No one can ever take that from you.
All right. I'm just asking, do you ever like I don't know if you remember, but like when like you say, remember when I used to write chess articles?
Yeah. You want to still write chess articles?
Like-
You totally can.
I'm just asking, like, would you still want me to win that?
We're gonna do another chess tournament here soon.
I
For
don't
sure.
even think like that's the goal. If you put it on like a Saturday, I can't even play at all because I got my job here.
Oh,
But if
okay.
it's on like a Sunday, if it's on a Sunday, then I can make it.
Sunday's good.
As
All
long as
right,
Sunday
we'll do it on Sunday then. We'll do it on Sunday.
afternoon, like late in the afternoon. So like, how do I say 1 p.m. for you? Or well, no wait, are you 2 hours? Wait, what's your time right now?
It's 4:56.
4:56. So I'm the one who's 2 hours ahead of you. So if you put it at like 1 p, if you put it at like 2 p.m., then I can make it.
Okay. 2 p.m.
Yeah, you can
DM
say
me.
so for
DM me
for
what
your
times
time.
work for you, and then I'll work on it.
All right then, thanks. I'll see you.
Cool. Nice. All right, good job. We got this one done. Thanks so much for all the help. Appreciate the help, Anch. Have we had any math Olympiad shenanigans yet? Surprisingly not. We've had some like ugly as sin questions we've had to do for sure, but nothing has been like Olympiad level yet. Anyway, that was 12B, please. Did that question. Mark is done. I enjoy such questions. Yeah. I mean, I like a good roast every once in a while. All right. Da-na-na-na. Ba-na-na-na. Oh, wait. Someone asked like some crazy linear. Oh, thank you, Burrito. Burrito, I love your rainbow tech stuff. It's so fun. Nice. Burrito, do you want the math god role? I'm pretty much gonna call you an educator at this point because you've helped out a lot. Do you want math god or physics god, or do you want both? Both is fine. Cool. All right, there you go. You now have the roles, and I'll give you physics god. There you go. I appreciate you, Burrito. Thanks for going through and answering those questions. Yeah. There's a new channel you should be able to access. Penn Center's looking at maybe getting some help on some other streams he wants to do with like homework help. You should be able to access it in the Discord now. Congratulations. And again, I appreciate your help. Yeah, that's a beautiful example. So since we introduced the role of like assistant, or what is it, associate educator or whatnot, I've had like 25 people sign up for it, which is great. I'm really happy that people want to help. But the best way you can demonstrate to me that you can help is to do help. And you've been doing a really great job, Burrito, with going through and here, I'll show to the people on the Discord. Like, this is where all of our questions get posted on the stream. And then the ones I can't get through, they also get posted here eventually. So Burrito's been doing a really good job, like going through and helping out, answer some questions that I didn't get to. Yeah. Anch, did you sign up to be an educator as well? I love helping where I can. I miss teaching and tutoring. Well, you came to the right place. I'm not calling your stream boring, by the way. Listening to you solve problems in the background is great nap background noise. Nice. I'm so he's so cozy in bed right now. Oh, that's so nice. Wow. We're night. Well, also this music that I have generated is like literally like sleepy lo-fi vibes. You're gonna cook with your 100-year low? Nice. Yeah. Get some sleep, JC. Great Sudoku background stream too. Nice. Good. Okay, let's see the next question coming up. Comes from Odin Root H. Actually here, let me see Will's real quick. Is yours easy? Because Will, I know you just joined us from TikTok and you probably have to go. So let me just I do, if I see someone who's new, who's never answered a question before, and they're in the chat, I'm gonna go real quickly and just do theirs real quick. Just stay with me real quick. Let's see. So Will, if you're watching, I'll do this for you real fast. Okay, a contestant on a game show spins a wheel that is located at a plane perpendicular to the floor. He grabs the only red peg on the circumference of the wheel, which is 1.5 meters above the floor, and pushes it downward. The red peg reaches a minimum height of 0.25 meters above the floor and a maximum height of 2.75 above the floor. Sketch 2 cycles of the graph that represent the heights, and then determine. Oh, this is a great one. This is a good, cool little sign question. Yeah. So let's draw like a little graph, and let's like try to like see what's happening. Okay. So we know that the minimum is equal to 0.25. The max is equal to 2.75. I'm not even thinking. The picture, like, I don't know what the fuck's going on with this wheel. It just seems weird. Oh, I get. Oh, it's like a Wheel of Fortune thing. But oh wait, what's that? What's that game called? Price is Right. It's like a Price is Right wheel. I think I see what you're saying. I think it's like this. Yeah, someone's spinning a wheel like this. And they're saying that the highest point is like somewhere up here and like the lowest point's down here. And then like the red peg is something like this. Okay, I think I understand what's going on. Okay, but regardless of this like goofy ass picture, if you can just extract the math parts of it, we can kind of procedurally figure out what we need to do. So once you have the minimum and the maximum of a sinusoidal function, you can figure out what's called like the midline. And the midline is always just in between these 2 points, which is the average of the minimum and the max. So you're going to say 0.25 plus 2.75 divided by 2. So 0.25 plus 2.75 is 3. 3 over 2 is 1.5. Right? So this is nice. So already, I know my midline is here. Let's just call this the mid, right? And then we're going to draw like some dashes on it. Okay. And then the maximum is located up at 2.75. So let's put a max up here. Say this is the max. Then we'll do min. Do you have the McGraw-Hill Grave 12 textbook? I don't, but if you want to take a picture of a question that's in it on your phone, there's a website there, actualofficehours.com. I can probably answer whatever questions in the screenshot. All right, this was at 1.5. This is at 0.25. This was at 2.75. Excellent. Okay, and then here's the cool thing. They say they grab it, which is located at 1.5 above the floor, and they push it downwards. Okay, let's assume that this is time. And let's assume this is like height. Okay, so when time is equal to 0, they're actually grabbing it right at the midline. Do it right now. No, if you add it to the queue, I'll get to it eventually. There's kind of a line of people asking questions. But even if you have to go, Sophie or Soph, submit it anyways. Get it in the queue, and if I don't get to it during the stream, and we have an hour left, I can probably get to it. But if you have to go, also make sure to join our Discord, because the question will be answered, and the solution will be posted in the Discord. And then you can go back and watch the recording to see how it was done. Wait, bro, are you actually teaching math on Twitch? Yes. Yeah. If you need help, you came to the right place. Yeah, go submit a screenshot. I'll go over it. Is this physics? No, this is pre-calc. Yeah, and then there's the Discord too. Let me know if the link doesn't work. Some people are saying it was being weird on mobile. Okay, so it's here, right, Will? And then I know I push it down. So that means the graph is immediately going down. So it's going to do something like this, right? And then it's probably got to come back up to its original point. And then it's got to come up to a peak. And then it's got to go down again. And then it's got to go to the lowest point. And then it's got to come up. They want you to graph 2 cycles. Is that what they wanted? Oh, this is annoying, bro. What? Oh man, this is super long. Okay, wait. I'm gonna make this a little bit shorter, because otherwise we're gonna run out of room. Okay. Okay, there we go. The link for the Discord's invalid. Yeah, give me a second. It's because you're on mobile. Here, try this. Try this, Debate Lord. Okay, that's 2 cycles. The reason why it's 2 cycles is you want to always return to where you were, which is I was at the midline, but you also need to be doing the same behavior. So here I'm at the midline moving down. So this is not a full cycle because here I'm at the midline moving up. Here I'm at the midline moving down. So this is 1 cycle. And then, oh, actually, sorry, we didn't need to draw all this. Sorry, let me get rid of this. There we go. That's 2 cycles, right? So from here to here is 1 cycle, and from here to here is this is the next cycle. Okay? So that's 2 cycles. And now they want, as a function of the total distance... Wait. Sketch 2 graphs that represent the height of the peg above the floor as a function of the total distance moved. Oh, okay. Oh, very interesting. Okay. They're being tricky here, by the way. They are being very tricky here. Okay. So, it's a circle. Exactly, Jeff. So, when you have the peg here, which is at the midpoint, and it goes around and does 1 cycle, okay? How much distance has it moved, right? So if the peg here, right, gets, and the wheel spins around, and it comes back to its original position, the total distance it moved is equal to the circumference of this circle, right? So, in this case, the quote-unquote, like, period, it's not the time, it's the circumference. Period refers to what needs to change in order for you to return back to your original position. Most cases, this is a time. You say, like, something is here at 1 second, and then it takes another 4 seconds for it to get back to that same position. So you say the period's 4 seconds. And, yeah, exactly. So, yeah, here's how you find the period. So the period, in this case, is not a time. It's not a time. It's a distance, which is weird. I've never seen this before, Will, by the way. This is actually pretty cool. But it's whatever this x-axis is. It's whatever is evolving the position of this thing. In this case, it's how far the thing has moved. Usually it's time. Usually it's as time moves forward, my position oscillates. In this case, it's how far I've moved is now showing, like, what height I'm at. Okay, so the period's equal to the circumference. And the circumference for a circle is equal to 2 pi r. Alright, so if we want to figure out what the radius is, notice that the radius is the distance from, like, the midline to the top, which is the difference from here to here. So this is equal to 2 pi, and then this different distance is 1.25, right? Because at the midline, right, when you're at the middle of the circle, you're 1.5 meters off the ground, and then when the dot goes all the way to the top of the circle, you're now at 2.75. So that was a total change of 1.25. Does that make sense why the radius is 1.25 for the circle? Cool. Okay. So then your period is equal to 2.5 pi. Cool. 2.5 pi. That's equal to period. All right, so let's try to build this function. Okay, so some other key things we needed, right? We needed the amplitude. So in this case, the amplitude is always equal to, like, max minus min divided by 2, which that's 2.5 over 2. That's equal to 1.25, which is also the radius. So, also, what type of function does this look like, right? This almost looks like sine, right? It's starting at the midline, but sine would usually do this. Sine would go up and come down like this. This case, sine is going down and then up. So it's flipped. So I'm going to say y is equal to negative sine. And then this is going to be omega x plus c. And then we need to put like an amplitude here. So this is the general form, right? Y is equal to amplitude sine. This omega is equal to 2 pi over the period. So period's also equal to this kind of like this fancy t. So that's going to be equal to 2 pi over 2.5 pi. So this will cancel. And you end up getting 4/5, right? It's just 4/5. And then this is the midline. And then this right here is the amplitude. Okay? So your final equation is y is equal to negative 1.25 sine of 4/5 x plus 1.5. And there you go. That's it. Nice. Cool question.
Well done. Well done.
Now, if you wanted to what's the 1.5? The 1.5 is the midline. So that's like the vertical displacement, right? Sine usually starts at y equals 0. Here I need sine to start at 1.5. So that's why there's a displacement. And then, again, if your teacher wanted you to label this, right, you know this is 2.5 pi. So then this must be 5 pi. And then, right, the halfway point, this would be 1.25. What's my main job? I teach a lot. I've taught at UCLA. I teach privately. I do this. This is a nonprofit I run. And then I also do some consulting for edtech startups. Right, and then this is 0. And then if you wanted this would be like the halfway between, but like whatever, just do 1.25 divided by 2. Right, okay. And so then this would be 3.75 pi. Because that's like the halfway point for this. If your teacher's getting like, I don't know, like weird and like wants you to label those. I live in Los Angeles. Anyways, nice. Will, hope that helped you out. I'm going to download this for you. So this was Will's question. And then what you should see, Will, if you're part of our Discord, is if your question will show up here in the homework help channel. So let's see. There we go. There's Will's question. And then I'm just going to drag this into it. I can definitely teach derivatives. Greetings from Serbia. Dzień dobry. Or is that Polish? They're kind of all the same Slavic languages, aren't they? Yes, you can always send a question, but there you go. There is a solution for you, Will, if you want to take a look at it. It's there in the Discord. We will probably definitely be doing more trig stuff. We do love trig. It's Polish, maybe? Yeah, I have a lot of Polish friends. All right, nice. But yeah, for those of you just watching us, the website is actualofficehours.com. You can put in your username, drag in a screenshot, hit upload. It'll get added here to the live queue. And so, this next question is from Odinroot. What do you got for me, Drew? Ooh, this is cool. We got some triangles coming up. Clickbait's got some quantum mechanics, I think in Cartesian. Spherical coordinates. DM's got, this looks like a biology question coming up. This is a high school question. And then physics. I love physics. Cool. Yeah, this is diffraction interference. Yeah, I do all sorts of stuff. I do anything math or science. I say middle school up through college. And if I can't do it, I have an awesome team of other partners and friends who also love to teach and know different things, and they can sometimes fill in for me and help out. Because I don't know everything, but I know a lot of things. Like, I might get screwed on this one, honestly. Odin, dude. Odin, bro, I benched 245 today. Here, I got a picture of it somewhere here. I'll put it up for him. Odin loves talking about my gains. Where is it? This is our Instagram. ChatGPT is also useful, 100%. Where is it, Odin? Let's show you. This was my weekend. I had a lot going on this weekend. There we go, Odin. Odin, I hit 245, dude. For 4, by the way. I did 245 for 4. Big muscles here, dude. Okay. Use cylindrical coordinates. Boo, this weekend is Peruvian Chemistry Olympiad, and my pupil has just caught the flu. Oh, no. That sucks, dude. Are they going to be able to compete? Or are you going to, like, drag them full of, like, Tamiflu and be like, yo, you have to do this? The weather in LA is beautiful. I think it's literally probably 70 degrees. The volume of the region between the XY plane and the cone z equals square root of x squared plus y squared over the disk 0 is less than 4. Do not solve the triple integral. Yeah, that sucks, dude. All right, let's do it. So I'm gonna assume this is like kind of cylindrical-y, right? Z equals the square root of x squared plus y squared. Oh, this is z squared equals x squared plus y squared. Oh, I see. Is that a cone that just looks like this, literally, right? I think it's just this. The volume of the region between the XY plane. So this is all the XY plane. And the cone over the disk 0 to 4. Okay, well this automatically tells me things about Z, right? So this tells me that Z goes from 0 to 2. Yes, thank you, Leckle. Absolutely correct, right? Because x squared plus y squared is at most 4. So the square root of 4 is 2. So Z is at most 2. Okay. So we got kind of like... Here, and then let's like throw this thing up. Oh, I don't think this is too bad then. Okay, so I think I want this area then, right? I want, like the negative of the... Whatever, the ice cream cone. Between the XY plane and the cone. Okay, cool. Volume. Let me... what is volume in cylindrical? Here it is. Seems legit. Actually, I think I want this. Okay. So if I wanted the whole volume, let's just say without even the cone doing shit, right? Let's just say I wanted the volume of the cylinder, right? That would be the triple integral of just dv. And dv in this case is r dr d phi dz. So r dr d phi. Is it? I thought Penn Center's stream starts in... Wait, what? Oh, he may have moved his. No, his stream starts at 6. I still got 40 minutes left. Yeah, it's a triple integral. Yeah, because you're finding a volume. Oh, well, maybe he's starting early. That's cool. Well, whatever he wants to do, I don't care. We'll still raid him afterwards. Okay, so this would go from 0 to R, phi would go from 0 to 2 pi, and then z would go from like 0 to z. In this case, I appreciate the resource. My office hours are at inconvenient times. Yeah, they can definitely be like that. Okay, whenever I see triple integrals, I always like to kind of like work from like outside in. Okay, so let's consider what's happening. I know in terms of dz, in terms of the height, I need to go from a lowest z of equal to 0 to a highest height of z is equal to 2, right? Agree with that? So here, I'm going to say that this part of the integral is going to be going from 0 to 2. And then that's the dz component. Let's think about d phi. Well, I think d phi, so as I go here, I am definitely going to integrate all the way around. So the 0 to 2 pi is fine. We can keep that as well. 0 to 2 pi d phi. Okay, where things get weird, though, is the r. Because I'm not integrating from 0 out to r. That changes as a function of z, right? Any tips for drawing shapes? Yeah, exactly. Sarah, my best tip is work from the outside and then work your way in. Like, this automatically tells me that I need a shape that is in the z-axis from 0 to 2. So it's like all of this space. And then as we do that, think about, okay, the next thing, how does theta restrict it? As we go from 0 to 2 in terms of z, what am I doing with theta? Well, there's no restriction in theta. Yes. Yes, and let's get to the last part here. So, phi or theta, whatever, goes from 0 to 2 pi, because I need to go all the way around to capture that area. But then, we don't go from 0 to r as we go up, right? So, in fact, when I'm, for instance, let's say at this height, z, right? My r needs to only go from here to here. So the outer boundary will definitely be r. So I can definitely say, okay, we are definitely going from like something to like, did they give me an r? Oh, and the radius of this thing is 2, right? Because x squared plus y squared has to be less than or equal to 4. So that tells me the radius is equal to 2, right? Radius equals 0 to 2. So here we're also going to go to 2. But the radius I start at is like some r inner, okay? So if I am, for instance, here, right? This is my r inner. And I need to figure out how to describe that in terms of other variables. So, this is a triangle, right? Whereby, I think I'm going to use this thing. Z is equal to, yeah, look. So, Z is equal to R. Because this is, right, square root of x squared plus y squared. Oh, this is very cool. Okay. Ooh, I see this. So this R inner is literally just equal to Z. And that makes sense, right? Because when you're at the bottom, Z equals 0. Your inner radius is 0. So you go all the way from 0 to big R, which is 2. And then when you're all the way at the top, right, at 2, when Z equals 2, now you're going from 2 to 2. So there's no real area there. Okay, this is very cool. Now, does that make sense, Odin? This is going to go from Z to 2. It's going to go from Z to 2. And then that's RDR. Gold, who are you spending winter with? Myself? Are you asking if like I have a girlfriend? Like what are you asking, dude? I'm not gonna go see my family. No, we're gonna meet in like January. A lot of my family's in some sort of like medical healthcare thing, so it's very difficult for them to get off Christmas. Because I think, yeah, 2 of my sisters are nurses. My dad's a doctor, and then like another one of my sisters is a doctor. So like we can't really get Christmas off. Does that mean more time to stream? Yes and no. I think I am going to take a little bit of a break once the school year ends, or once like the winter whatever quarter ends, just to like kind of like catch up on things. Didn't you have a date? Did I have a date? I can't remember last time I had a date. Probably a couple of months ago. Anyways, I can definitely help with rotational kinematics. Joke says, when evaluating triple integrals, if I have a constant, I can pull it out of the integrals, correct? Yes. Yeah, numbers you can pull out. Also, if I'm doing U-sub and I have to change the bounds, do I have to change 1 or 3 bounds? No, you just have to change the bounds of the variable you're messing with. This is cylindrical, yeah. Okay, cool. Nice. Good job, Odin. That's a really cool question. Nice. I appreciate it. Well done. Dude, we've had like some really nice questions today. I haven't felt like too much rage from like a math Olympiad's question yet. No one's really tried to test me yet. Nice. We should play a lot of games. Yeah, we should play a lot of games. We probably will. What a prestigious family, though. Yeah, well, I don't know about prestigious. We're not really prestigious at all, but my parents definitely emphasized a lot of importance on education. I mean, that's why I'm here. Educated, yes, yeah. Prestigious is I think usually what is prestige? That's like if you all go to like Harvard or some fucking shit. Like fuck that. Bunch of like snobby people. Educated, yeah. My family is very well educated. I'll say that, yeah. We all do something, and I mean, one of my sisters is a lawyer. One of my sisters is now a baker. Actually, yeah, she went to culinary school. She's baking like pastries and shit. 2 of my sisters are nurses. And then what is the other one? Oh, the other one's a doctor. There we go. Yeah, I have a lot of sisters. I just got back into integrals in Calc 1. Is there anything I should be aware of going into integrals further? Just know all the rules, I guess. There are a lot of fun rules, right? All the different tests. I think if you're getting into integrals in Calc 1, you really want to make sure you know your trig, because there is like trig substitution starts to deal with a lot of trig stuff. Yeah, I do have 5 siblings. Yeah, I have 5 sisters. I have 0 brothers, and I'm the oldest. There's a lot of unique things that happen in my family. Also, like sequences and series become very important as you start getting further into calc. Okay, 3 small identical neutral metal balls are all at the vertices of an equilateral triangle. The balls are in turn touched to an isolated charge conducting sphere whose center is on a line perpendicular to the plane of the triangle and passing through the center. As a result, the first and second balls have acquired charges Q1 and Q2. The charge acquired by the third ball is... Assume the charge and potential of the large spherical conductor change insignificantly. What's up, Bree? Yeah, well, shit. Don't forget trig. Don't do it. Don't do it. Anyways, what is this question, dude?
What the fuck is this piece of shit?
Okay. Equilateral triangle. I think something like this, right? And we have neutral balls. Yes. Yeah, definitely learn. Yeah, trig identities. Go learn those again. Refresh them. There's a really good table on them, actually, if you want. I always pull it up. Where is she? This one. Yeah, this one, I don't know. I always find myself, like, referencing this. This is a really good one. Just look up like trig identities on like Google. It's like one of the links. Or here, I'll drop the link for it for you. Copy image link. Where's my chat? There you go. There it is. Leckel thinks the answer is B. Well, let's see. Are in turn touched to an isolated large charge. Okay, so let's assume this is charging by conduction, right? Isn't that what this is? And it's isolated, so okay. So you have, am I done at 6? Yes, 29 minutes from now, I'm done. But we will be streaming tomorrow. And if you're watching, make sure you go to the website, actualofficehours.com. You can click on the streaming schedule here, and you can see the next time we're streaming and the next time other people are streaming. So, for instance, Penn Center is going to be doing some more help if you want to help with him. This is where he's going to be streaming. And then if you're in the UK or EU, Joseph, shout out Joseph, is going to be streaming tomorrow early morning Pacific, which is, I think, kind of afternoon European time. But he's on Twitch as well. So go to the website, check out the calendar. You can find out all the different times other people are streaming. All right, let's assume this has like a big charge Q. All right? And let's say we take this big charge Q and we go and we touch it to this one. Okay, when we do that, okay, these charges are, because this is neutral, it has a charge of 0, the charges will equilibrate, which means they will try to like average each other out. So now, and let's say this is like charge 1, charge 2, charge 3. Charge 1 is now going to take on half of the big Q. So this will be Q over 2, and then Q over 2 will be left on this. Okay? Alright, now I'm going to go move it somewhere else. Let's go take it and hit it with this charge. Okay? This again has a charge of 0, so it's going to take half of that. So this is going to be Q over 4, and this is going to be Q over 4. And then finally, we're going to take this and touch it to the third one. And then this will have Q over 8 in order to average out with what's left here. Q over 8. Okay. The charge required by the third ball is, well, it's Q over 8, which is technically Q1 over Q2. So wait, I have to figure out like which way this works. They're definitely not the same. Is it 2Q2 minus Q1? No, that's 0. Is it Q2 squared over Q1? So that's 1/16 divided by 1/2. Oh yeah. That's 2 over 16, which is equal to 1/8. So it is this one. Okay, cool. Answer choice is B. Nice. You were right, Leckel. Does that make sense, Drew? Yeah, it's just every time you touch it, the charges equilibrate. But this is a... Do you know about charging by induction, Drew? This is different. This is charging by conduction, which means the things touch each other. There's also, like, charging by induction, which is if you just get stuff close to it, you can kind of, like, induce charges. It's a really cool concept. If you don't know it, let me know. I'll explain it. Droove. All right, nice. There we go. I do love physics. It is what I got my PhD in. But yeah, the other cool thing to do would be charging by induction diagram. And this is pretty cool. Here, let's just watch this like real quick. It is pretty fun. Yes, there we go. This is what I want. Okay. So this is an example of you have a charged rod and you have a neutral sphere. Neutral means it has equal numbers of positive and negative charges. Ooh, mine's in plasma physics, Leckel. What's yours in? If you want it, I added a new link because people keep asking me like what my credentials are or like what my thesis is. If you go to this website, actualofficehours.com, down here in the bio, that has links to my my LinkedIn, my thesis. You can go read all this stuff there if you want. Anyways, okay, so if you have something neutral, and here, let's put this in like a kind of like a diagram here for you. It's pretty cool. Okay. Quantum mechanics. Oh, nice. Leckel, I would welcome you in my Discord, dude. I do have people asking quantum questions that like I just can't answer. Oh, no. I got a B- in quantum in grad school. I technically failed it. I'm not the best at quantum. I don't know, it just mind boggles me sometimes. Yesterday we got blue balls, now we're touching balls.
Nice. Perfect.
Yeah. Okay. This is neutral, right? Because it has equal number of negative and positive charges. If you bring something that is positively charged close to it, it will start attracting the negative charges because opposites attract. And by contrast, it'll start pushing away the positive charges. So originally this thing had like positive and negative charges mixed everywhere. But when you bring something positive next to it, it starts to pull the negative stuff to the left and starts to push the positive stuff to the right. This is now polarized because it has poles, right? It has a negative pole and a positive pole. All right. If you then connect the sphere to ground, ground is like the Earth, which is an infinite source of negative charges. Now what happened is that all these positive charges that don't want to be next to this other positive rod that's coming close because they're scared, they run away to the ground. And so this thing ends up being negative. And now what happens, if you then disconnect this ground, now the positive charges can't come back. So you've like cut off their path. So once you bring this positively charged rod away, now the net charge is negative. Because we scared off all the positive charges. If you left it connected to ground, the second you pulled this thing away, all the positive charges would have rushed back in. So yeah, it's a pretty cool concept, but that's how you can charge things without even touching them. You just kind of like force them to move, and then you like cut off their return. Okay, I got 23 minutes. We can still do some clickbait. What are you gonna do? What are you doing to me, clickbait? Yo, speaking of quantum, Leckle, you wanna help me here, dude? Speaking of quantum, this is quantum mechanics. By the way, I never understood what ground is. I understand it's a potential of 0 volts, but like, is it actually the ground? Because I've seen diagrams showing it literally stuck in the ground as ground. Yeah, the Earth is literally ground. Really, what we like to think of is that the ground is... The Earth is just an infinitely neutral thing, so it has an infinite source of positive and negative charges in it. So, if... and it's able to like absorb external charges like really easily. It's like a juggernaut. It's huge. Physics is a shit. Physics is a shit, dude. Yeah, hell yeah. Dirt does it conduct electricity? If there's a high enough of a potential, it does. That's what lightning is. You're right. In general, it does not. But if things want to go there, they will. Speak of the devil, and it shall arrive, I guess, right? Yeah, Bree. This is quantum mechanics. Prove that LZ is negative IH bar DD phi. Use the chain rule. Okay, so wait. L is angular momentum, no, right? Is that the momentum operator? L squared. Is there also like why are they putting a dot above this equal sign, dude? This is suspicious, dude. What's the dot over the equal? Is it like kind of equal to it? Oh, it's defined. The dot means approximately. Well, I thought approximately was this. This is approximately. What is the dot? Burrito thinks it's defined as that. Maybe. Okay. Prove that. Why is L plus or minus 1/2 in chemistry? But we use that same symbol for angular momentum. Yeah, because that refers to like the spin, right? Is that the spin? Spin of an electron, right? Okay. Use the chain rule to write the Cartesian derivatives in terms of spherical coordinates. So, yeah, L is spin, right? Yeah. Well, there's like M sub L, M sub S, right? And that's like, it's like spin number. I asked Google, and it is approximately. Okay, thank you, Grantis Atlantis. Grant to Solantis on the equal sign. Yeah. The dot and the equal sign. Okay. I agree ddx is dx, dr dx, ddr, d phi dx, d phi, d theta, sorry, d phi dx, d phi. Orbital angular momentum. I think it's, maybe it's spin. I think L is spin. Kent is also, Kent is like a chemistry professor. Kent knows a lot of good things about chem. Fragi says, amazing. You were the first person doing something meaningful on live, not just for clicks. I can do the yummy, yummy. Ooh, yeah. I can do that. You guys want me to do that? Is that more entertaining? Z component of the angular momentum operator. Oh, okay, fuck. All right. Okay. I'm trying to understand what's going on here. Okay. So R is equal to this. I agree. Theta is this. This is how we go from spherical, right? Because theta is equal to the arc cosine of Z over R. Cool, and this is Z, this is R. And then phi is equal to the arc tangent of Y over X. Right, because if you do Y over X, these cancel. You get sine phi over cosine phi, which is tangent phi. Arc cosine. Cool. L is spin because spin is defined as the rate of which state changes. Okay. I'm going to trust Leckel because he has a PhD in quantum mechanics. Mine is only in plasma physics. All right, so we do... So wait, the question here, are we just going through this clickbait or is there a question to it? Oh, am I supposed to like substitute all this shit into here? Is that what they want you to do? That's just fucking cruel and unusual. This is, I would say, upper division college physics. Probably, maybe first year graduate school. The proof, yes. The proof, Sam. Okay. All right. Okay. L squared is defined as this. So this is the magnitude of L, right? So what? L squared is equal to Lx squared plus Ly squared plus Lz squared. This is what Mathematica is for. It's the German professor that wants us to sharpen our teeth. What? So you can like drill holes in your brain? This is, dude, what's the point of sharpening your teeth on this? This is just painful. Okay, drdx is... Yes. Is x over r. Why is that? Oh, okay, yeah. Because, well, shouldn't there... Oh, okay, yep. I respect it. I do too. Negative I bar h is the viscosity component of the spin, which is how the spin is affected by the outer charge. Yeah, no. They are just normal and trig functions. That's all they are. Yeah. Bree, you're right. Bar h is the reduced Planck constant. Yeah, it's like arc. Yeah. Where you submit homework? Actualofficehours.com. Yeah. So real quick. So if you have, for instance, like the sine of theta is equal to right opposite over hypotenuse, and this is like a number, you can take the arc sine of both sides. And what that does is that strips the sine off. So then you get that the angle is equal to the arc sine of opposite over hypotenuse. So arc sine of something is saying, what is my angle such that if I took the sine of that angle, I would have gotten this number. I would have gotten this ratio. This question is a skip. I don't want to skip it. I think it's cool. I might though, just because we have 15 minutes left. But again, even if the question is difficult, there's a lot of things to learn from it. So, for instance, learning about yes, arc trig functions, inverse trig functions. Sorry. This is also not plug-in. Okay, Leckel, because I'm probably at like my limits of being able to do this question, especially in like the 15 minutes I have left. Do you wanna help out with this question? I know Clickbait would really appreciate it. I don't know if you're feeling like you want to have some fun. I'm gonna post this in our Discord. Is what I'm gonna do. Yes, you're right. Yeah. Technically, you can prove it with vectors. Okay. So yeah, here's what I'm gonna do. I'm gonna mark this as done. Which is gonna put it into our Discord. So our Discord is right here. So if you go to Homework Help, this channel right here, Homework Help, you'll see the question get posted, which is, where is it? There you go. And here's this question. And I'm gonna mark this as unsolved. And I'm also gonna like tag the physics gods in it. So if they want to like take a stab at it. Also, Clickbait, if this doesn't get answered in 2 days, we have a bot that will go through and just sick a bunch of ChatGPT credit on it. That's been happening with a couple questions. Yeah, this one, for instance. Actually, oh no, Joseph, you answered this one. Oh, thank you, Joseph. That's really cool. Yeah, this is what I love. I love that you guys are going through and like helping answer things. 555. Oh, you tried to answer this too? Fuck yeah, 5K. Thank you, dude. You guys are great. Yeah, I love this. I love when my community just is being helpful and stuff. You can always skip mine. I'm gonna grind through it. Okay, that's okay. All right, we got 13 minutes. Let me see what I can get done. We got 4 left in the queue. All right, next one is from DM's Scrader. Oh man, what is this? This looks like biology. I like being exposed to your questions, Clickbait. They're fun. Because some of them I can't answer. Okay. 2 plants are crossed. The first one is heterozygous for seed color and homozygous recessive for flower color. The second is heterozygous for seed color and homozygous dominant for flower color. Green seeds are dominant over yellow. White flowers are dominant over purple flowers. If I have time, Hbaka. If I don't worry. It'll get put into the Discord and someone else will definitely do it. Or I will do it later. But I do have to go in 12 minutes. Okay, so I think we have to come up with something for this. So let's talk about like what a trait would be. Let's talk about seed color. And then the other one is flower color. So let's do flower. So the genotype. Genotype is let me remember. Genotype is like dominant or recessive. So let's say like big S and little s. And then the phenotype, right, is that it can either be where is it? The seed color. Green seeds are dominant over yellow. So green is dominant over yellow. Oh, I see. Okay. Here we go. If it's big S, little s, or big S, that's green. If it's little s, that's yellow. Right? Because this is homozygous recessive, and this is heterozygous and homozygous dominant. Okay. Flower color. So you can either be white, or you can be purple. And for that, capital F, little f, or capital F will cause white. Little f will cause purple. Very cool. Okay, the genotype for parent 1. Okay. The first is heterozygous for seed color. Okay, so this is S, little s. I think I want to do it this way, actually. Sorry. I think I want to do it this way. I want to say S, little s. Oh, my little s is going to look weird. Fuck. Let's do this. Let's do that for capital S. Little s. And then it's homozygous recessive for flower color. So that's little f. And then this one is heterozygous for seed color. So that's big S, little s. And homozygous dominant. So then that's big F. You use dollar signs. Oh, that's a smart idea. You mean for capital S? Yeah, I'm going to help with this. Okay. So, you could have big S, big S. You're just foiling is what you're doing. You could have, big S, little s. And then you could have... Almost done, boss. Yeah, I know. We're getting there. Wait, ooh, wait, how does this work? I don't want these to cross with each other. Fuck, wait, how does this work? I gotta remember. It's a dihybrid cross. Yes, I am doing it wrong. Thank you. Yeah, let me fix this. Oh, sorry, wait, let me look up real quick. I need to remember what dihybrid cross is. Oh, okay. Yes, okay, there we go. I got it. Got it. I think I got it. Find the gametes and then cross them. So, and wait, this is like the one person then the other person, right? Ew, Punnett squares. Yeah, okay. So this is like, I think like plant 1, right? And then this is like plant 2. 1, 2, 3, 4. 1, 2, 3, 4, and you get a 4 by 4. Okay, great. So, parent 1 has this genotype, right? It has capital S, little s, and then it has big F, and then the other one is capital S, and then it's little f. Okay, this is the foil thing they talk about. So you can either have this with this or this with this. It has to send one of the S genes, and then it has to send one of the F genes. So and those are gametes. That's how like babies are made. Like, you send like a package, and there's like a random selection of packages you could send. Right. So here's all the possible ones. So you could have big S with big F. You could also have big S with big F, because that's with this, and then that's with this. Then you could have little s with big F or little s with big F, right? Okay? This one, big S with little f, big S with little f, little s with little f, little s with little f. So you're doing that one, that's these two, and then you do this one. I can see these two. Okay. Now I think I see what you do. You put all the gametes for parent 1 up here. So this is big S, big F, big S, big F, little s, big F, little s, big F. This is big S, little f, big S, little f, little s, little f, little s, little f. And then you cross all them. So then this is big S, F, little f, big S. Oh man, I'm gonna say so many F's and S's, dude. I'm gonna like lose my fucking shit, dude. Here, what? Oh man. Okay. This is probably gonna be the last question because it's just kind of a pain. Do you understand how I'm doing this, DMs, by the way? So for instance, I'm taking this one with this one. So you have, you do all the S's. So this is big S, that's why this is here. And then it's big F, little f. That's why I wrote big F, little f. It is very tedious. It's incredibly tedious. Yeah. But sometimes schoolwork do be like that, you know? Oh, wait. This is little s, little f, big F, little f. This is SS, big F, little f. Oh, these are copies of each other, right? Oh, it's the same fucking... Oh, I only have to do this one and this one. Then we can just copy it. Oh, I'm so dumb. Where can we watch other lives? They're gonna be on Twitch. So again, if you go to this website, actualofficehours.com, I highly recommend you click the watch live on Twitch, because then what'll happen is when this show ends, I will take us to another person on Twitch who is also doing science. So unfortunately, TikTok doesn't allow you to really raid or like take people to other streams, but Twitch does. All right. Cool. There we go. That's all of them. All right. Green seeds and white flowers. So green seeds is either... Okay. So green seeds and white flowers is like any like big S or big F in it, right? Because it's dominant. The second you see a big S in it, it's automatically going to be green. And then the second you see a big F in there, it's automatically going to be white. Right? So green seeds, remember green seeds could either be big S, little s, or big S, big S. And then white flowers is also either like big F, little f, or big F, big F. So really you just need to find a capital in each of them. So which ones have capitals in each of them? And again, remember that isn't it big S, little s? Well, no. White is dominant, right? White is dominant. So that's big F, little f, or big F, big F. And then green seeds is either big S, little s, or big S, big S. So, I already see it. It's like this. Oh, I gotta reload. Sorry, I've hit 3 hours on this. 1 sec. I'm just gonna go all the way back. Nomad, submit a screenshot. I can't really do things in chat. There's too much going on in my chat. Okay. So let's call this like the green ones. Okay. So green seeds. So that's this. It's not these. All right. Because these are both little s's. Actualofficehours.com. That website down there. Oh, it's also all these. Yeah, okay. So, all of them except 4. So, 12. Green seeds and purple flowers. So, purple flowers is the little f's. I don't see anywhere where you have 2 little f's, right? And the reason for that is these are all big F's and these are all little f's. So, there's no way for you to get 2 little f's. So, that's 0. Yellow seeds... That was possible. That's little s, little s. And white flowers, that's these. That's 4. And then, right, there's no way to get purple flowers. That's also 0. There you go. Nice. Fun question. I thought it was pretty cool.
Well done.
All right, nice. Good question, DMs. I'm going to put that. So, there's a screenshot for you. And then I'll give you a bond coin as well. Good job asking a question. All right, I have a minute. No, I have 12 seconds left. Okay, sorry. I do have to end the stream. But, okay, well, there's only 3 questions we didn't get to. So, this one looks really fun. I don't know how you remember how that works. I've just done it all. I do want to do this one. This is interference. And then, ooh, this one. This is a great math question for either Zach or Penn. And then the line segments. I like this. Okay, also good math questions. Okay, I do unfortunately have to go, so let me close the stream out. All right, thank you everyone for coming to Actual Education Office Hours today. Appreciate all the questions you guys have asked. Again, if I didn't have time to get to your question yet, so this is my next calendar event. I have to go watch an Eagles game. It's so funny. I do have this link to my calendar showing what I have next. But not to worry, it will get added to our Discord, and we have other great streamers and other helpers that would probably answer it at some point. So make sure to join the Discord. Make sure also to check out the streaming schedule. So the streaming schedule tells you when other people are streaming. So for instance, Penn Center, we're gonna go raid him right now on Twitch. And then also Joseph, if Joseph gets some sleep, Joseph, go get some sleep, dude. Is gonna have a stream earlier in the morning Pacific time, but later in the afternoon for you European people. So go check him out. Okay, cool. And again, yeah, if you found us on TikTok or YouTube, give us a follow on Twitch as well, because here, this is where we're gonna go to go see another streamer. So I'm gonna go to my stream manager real quick here, and we're gonna go raid I think Penn Center. Early in the afternoon, literally afternoon, early in the morning. It is, I know, it's too funny. Burrito says he can do the ODE one if no one gets to it. Awesome, yes. So if you ask the ODE question, Burrito is an awesome actual educator who also knows about math and stuff. Yes, have a great time. Okay, awesome, cool. Let's go raid somebody. We're gonna go say hi to Penn Center, who's doing some cool stuff in data science and statistics. So if you want to learn about how to be a data scientist, make tons of money with AI and stuff, go check out Penn. All right. Tomorrow's stream will start at 4 o'clock Pacific, 5 p.m. Central, 5 p.m. Mountain, 6 p.m. Central, 7 p.m. Eastern. Yes. All right. Enjoy the start of the week. We will see you guys tomorrow. Peace.
Brace yourselves, everyone. Yo, Taco Cat, how's it going, my dude? Yeah, Naive Base can handle